A company needs to improve the reliability of its ticketing application. The application runs on an Amazon Elastic Container Service, Amazon ECS cluster. The company uses Amazon CloudFront to serve the application. A single ECS service of the ECS cluster is the CloudFront distribution's origin. The application allows only a specific number of active users to enter a ticket purchasing flow. These users are identified by an encrypted attribute in their JSON Web Token, JWT. All other users are redirected to a waiting room module until there is available capacity for purchasing. The application is experiencing high loads. The waiting room module is working as designed, but load on the waiting room is disrupting the application's availability. This disruption is negatively affecting the application's ticket sale transactions. Which solution will provide the most reliability for ticket sale transactions during periods of high load? A. Create a separate service in the ECS cluster for the waiting room. Use a separate scaling configuration. Ensure that the ticketing service uses the JWT information and appropriately forwards requests to the waiting room service. B. Move the application to an Amazon Elastic Kubernetes service, Amazon EKS cluster. Split the waiting room module into a pod that is separate from the ticketing pod. Make the ticketing pod part of a stateful set. Ensure that the ticketing pod uses the JWT information and appropriately forwards requests to the waiting room pod. C. Create a separate service in the ECS cluster for the waiting room. Use a separate scaling configuration. Create a CloudFront function that inspects the JWT information and appropriately forwards requests to the ticketing service or the waiting room service. D. Move the application to an Amazon Elastic Kubernetes service, Amazon EKS cluster. Split the waiting room module into a pod that is separate from the ticketing pod. Use AWS App Mesh by provisioning the App Mesh controller for Kubernetes. Enable MTLS authentication and service-to-service authentication for communication between the ticketing pod and the waiting room pod. Ensure that the ticketing pod uses the JWT information and appropriately forwards requests to the waiting room pod. A company needs to migrate 60 on-premises legacy applications to AWS. The applications are based on the NET framework and run on Windows. The company needs a solution that minimizes migration time and requires no application code changes. The company also does not want to manage the infrastructure. Which solution will meet these requirements? A. Refactor the applications and containerize them by using AWS Toolkit for NET refactoring. Use Amazon Elastic Container Service, Amazon ECS, with the Fargate launch type to host the containerized applications. B. Use the Windows Web Application Migration Assistant to migrate the applications to AWS Elastic Beanstalk. Use Elastic Beanstalk to deploy and manage the applications. C. Use the Windows Web Application Migration Assistant to migrate the applications to Amazon EC2 instances. Use the EC2 instances to deploy and manage the applications. D. Refactor the applications and containerize them by using AWS Toolkit for NET refactoring. Use Amazon Elastic Kubernetes Service, Amazon EKS, with the Fargate launch type to host the containerized applications. A company is deploying a new web-based application and needs a storage solution for the Linux application servers. The company wants to create a single location for updates to application data for all instances. The active dataset will be up to 100 gigabytes in size. A solutions architect has determined that peak operations will occur for 3 hours daily and will require a total of 225 MB/s of read throughput. The solutions architect must design a multi-AZ solution that makes a copy of the data available in another AWS region for disaster recovery, drive. The DR copy has an RPO of less than 1 hour. Which solution will meet these requirements? A. Deploy a new Amazon Elastic File System, Amazon EFS, multi-AZ file system. Configure the file system for 75 MB of provisioned throughput. Implement replication to a file system in the DR region. B. Deploy a new Amazon FSx for Lustre file system. Configure bursting throughput mode for the file system. Use AWS backup to back up the file system to the DR region. C. Deploy a general-purpose SSD, GP3, Amazon Elastic Block Store, Amazon EBS, volume, with 225 MB of throughput. Enable multi-attach for the EBS volume. Use AWS Elastic Disaster Recovery to replicate the EBS volume to the DR region. D. Deploy an Amazon FSx for OpenZFS file system in both the production region and the DR region. Create an AWS DataSync scheduled task to replicate the data from the production file system to the DR file system every 10 minutes. A company is running a critical stateful web application on 2 Linux Amazon EC2 instances behind an application load balancer, ALB, with an Amazon RDS for MySQL database. The company hosts the DNS records for the application in Amazon Route 53. A solutions architect must recommend a solution to improve the resiliency of the application. The solution must meet the following objectives. Application tier, RPO of 2 minutes. RTO of 30 minutes. Database tier, RPO of 5 minutes. RTO of 30 minutes. The company does not want to make significant changes to the existing application architecture. The company must ensure optimal latency after a failover. Which solution will meet these requirements? A company uses AWS organizations for a multi-account setup in the AWS cloud. The company's finance team has a data processing application that uses AWS Lambda and Amazon DynamoDB. The company's marketing team wants to access the data that is stored in the DynamoDB table. The DynamoDB table contains confidential data. The marketing team can have access to only specific attributes of data in the DynamoDB table. The finance team and the marketing team have separate AWS accounts. What should a solutions architect do to provide the marketing team with the appropriate access to the DynamoDB table? A. Create an SCP to grant the marketing team's AWS account access to the specific attributes of the DynamoDB table. Attach the SCP to the OU of the finance team. B. Create an IAM role in the finance team's account by using IAM policy conditions for specific DynamoDB attributes. Fine-grained access control. Establish trust with the marketing team's account. In the marketing team's account, create an IAM role that has permissions to assume the IAM role in the finance team's account. C. Create a resource-based IAM policy that includes conditions for specific DynamoDB attributes. Fine-grained access control. Attach the policy to the DynamoDB table. In the marketing team's account, create an IAM role that has permissions to access the DynamoDB table in the finance team's account. D. Create an IAM role in the finance team's account to access the DynamoDB table. Use an IAM permissions boundary to limit the access to the specific attributes. In the marketing team's account, create an IAM role that has permissions to assume the IAM role in the finance team's account. A car rental company has built a serverless REST API to provide data to its mobile app. The app consists of an Amazon API gateway API with a regional endpoint, AWS Lambda functions, and an Amazon Aurora MySQL Serverless DB cluster. The company recently opened the API to mobile apps of partners. A significant increase in the number of requests resulted, causing sporadic database memory errors. Analysis of the API traffic indicates that clients are making multiple HTTP/GET requests for the same queries in a short period of time. Traffic is concentrated during business hours, with spikes around holidays and other events. The company needs to improve its ability to support the additional usage while minimizing the increase in costs associated with the solution. Which strategy meets these requirements? A. Convert the API Gateway Regional Endpoint to an edge-optimized endpoint. Enable caching in the production stage. B. Implement an Amazon ElastiCache for Redis cache to store the results of the database calls. Modify the Lambda functions to use the cache. C. Modify the Aurora Serverless DB cluster configuration to increase the maximum amount of available memory. D. Enable throttling in the API Gateway production stage. Set the rate and burst values to limit the incoming calls. A company has migrated an application from on-premises to AWS. The application frontend is a static website that runs on two Amazon EC2 instances behind an application load balancer, ALB. The application backend is a Python application that runs on three EC2 instances behind another ALB. The EC2 instances are large, general-purpose, on-demand instances that were sized to meet the on-premises specifications for peak usage of the application. The application averages hundreds of thousands of requests each month. However, the application is used mainly during lunchtime and receives minimal traffic during the rest of the day. A solutions architect needs to optimize the infrastructure cost of the application without negatively affecting the application availability. Which combination of steps will meet these requirements? Choose 2. A. Change all the EC2 instances to compute optimized instances that have the same number of cores as the existing EC2 instances. B. Move the application frontend to a static website that is hosted on Amazon S3. C. Deploy the application frontend by using AWS Elastic Beanstalk. Use the same instance type for the nodes. D. Change all the backend EC2 instances to Spot instances. E. Deploy the backend Python application to general-purpose burstable EC2 instances that have the same number of cores as the existing EC2 instances. A solutions architect is investigating an issue in which a company cannot establish new sessions in Amazon workspaces. An initial analysis indicates that the issue involves user profiles. The Amazon Workspaces environment is configured to use Amazon FSx for Windows File Server as the profile share storage. The FSx for Windows File Server file system is configured with 10 terabytes of storage. The solutions architect discovers that the file system has reached its maximum capacity. The solutions architect must ensure that users can regain access. The solution also must prevent the problem from occurring again. Which solution will meet these requirements? A. Remove old user profiles to create space. Migrate the user profiles to an Amazon FSx for Lustre file system. B. Increase capacity by using the update file system command. Implement an Amazon CloudWatch metric that monitors free space. Use Amazon Event Bridge to invoke an AWS Lambda function to increase capacity as required. C. Monitor the file system by using the free storage capacity metric in Amazon CloudWatch. Use AWS step functions to increase the capacity as required. D. Remove old user profiles to create space. Create an additional FSx for Windows File Server file system. Update the user profile redirection for 50% of the users to use the new file system. A solutions architect is designing an application to accept timesheet entries from employees on their mobile devices. Timesheets will be submitted weekly, with most of the submissions occurring on Friday. The data must be stored in a format that allows payroll administrators to run monthly reports. The infrastructure must be highly available and scale to match the rate of incoming data and reporting requests. Which combination of steps meets these requirements while minimizing operational overhead? Choose 2. A. Deploy the application to Amazon EC2 on-demand instances with load balancing across multiple availability zones. Use scheduled Amazon EC2 autoscaling to add capacity before the high volume of submissions on Fridays. B. Deploy the application in a container using Amazon Elastic Container Service, Amazon ECS, with load balancing across multiple availability zones. Use scheduled service autoscaling to add capacity before the high volume of submissions on Fridays. C. Deploy the application front-end to an Amazon S3 bucket served by Amazon CloudFront. Deploy the application backend using Amazon API Gateway with an AWS Lambda proxy integration. D. Store the timesheet submission data in Amazon Redshift. Use Amazon QuickSight to generate the reports using Amazon Redshift as the data source. E. Store the timesheet submission data in Amazon S3. Use Amazon Athena and Amazon QuickSight to generate the reports using Amazon S3 as the data source. A company has a data lake in Amazon S3 that needs to be accessed by hundreds of applications across many AWS accounts. The company's information security policy states that the S3 bucket must not be accessed over the public internet, and that each application should have the minimum permissions necessary to function. To meet these requirements, a solutions architect plans to use an S3 access point that is restricted to specific VPCs for each application. Which combination of steps should the solutions architect take to implement this solution? Choose 2. A. Create an S3 access point for each application in the AWS account that owns the S3 bucket. Configure each access point to be accessible only from the application's VPC. Update the bucket policy to require access from an access point. B. Create an interface endpoint for Amazon S3 in each application's VPC. Configure the endpoint policy to allow access to an S3 access point. Create a VPC gateway attachment for the S3 endpoint. C. Create a gateway endpoint for Amazon S3 in each application's VP. Configure the endpoint policy to allow access to an S3 access point. Specify the route table that is used to access the access point. D. Create an S3 access point for each application in each AWS account and attach the access points to the S3 bucket. Configure each access point to be accessible only from the application's VPC. Update the bucket policy to require access from an access point. E. Create a gateway endpoint for Amazon S3 in the data lake's VPC. Attach an endpoint policy to allow access to the S3 bucket. Specify the route table that is used to access the bucket. A company needs to gather data from an experiment in a remote location that does not have internet connectivity. During the experiment, sensors that are connected to a local network will generate 6 terabytes of data in a proprietary format over the course of 1 week. The sensors can be configured to upload their data files to an FTP server periodically, but the sensors do not have their own FTP server. The sensors also do not support other protocols. The company needs to collect the data centrally and move the data to object storage in the AWS cloud as soon as possible after the experiment. Which solution will meet these requirements? A. Order an AWS Snowball Edge Compute Optimized device. Connect the device to the local network. Configure AWS DataSync with a target bucket name and unload the data over NFS to the device. After the experiment, return the device to AWS so that the data can be loaded into Amazon S3. B. Order an AWS Snowcone device, including an Amazon Linux 2 AMI. Connect the device to the local network. Launch an Amazon EC2 instance on the device. Create a shell script that periodically downloads data from each sensor. After the experiment, return the device to AWS so that the data can be loaded as an Amazon Elastic Block Store, Amazon EBS volume. C. Order an AWS Snowcone device, including an Amazon Linux 2 AMI. Connect the device to the local network. Launch an Amazon EC2 instance on the device. Install and configure an FTP server on the EC2 instance. Configure the sensors to upload data to the EC2 instance. After the experiment, return the device to AWS so that the data can be loaded into Amazon S3. D. Order an AWS Snowcone device. Connect the device to the local network. Configure the device to use Amazon FSx. Configure the sensors to upload data to the device. Configure AWS DataSync on the device to synchronize the uploaded data with an Amazon S3 bucket. Return the device to AWS so that the data can be loaded as an Amazon Elastic Block Store, Amazon EBS volume. A company used AWS CloudFormation to create all new infrastructure in its AWS member accounts. The resources rarely change and are properly sized for the expected load. The monthly AWS bill is consistent. Occasionally, a developer creates a new resource for testing and forgets to remove the resource when the test is complete. Most of these tests last a few days before the resources are no longer needed. The company wants to automate the process of finding unused resources. A solutions architect needs to design a solution that determines whether the cost in the AWS bill is increasing. The solution must help identify resources that cause an increase in cost and must automatically notify the company's operations team. Which solution will meet these requirements? A. Turn on billing alerts. Use AWS Cost Explorer to determine the costs for the past month. Create an Amazon CloudWatch alarm for total estimated charges. Specify a cost threshold that is higher than the costs that Cost Explorer determined. Add a notification to alert the operations team if the alarm threshold is breached. B. Turn on billing alerts. Use AWS Cost Explorer to determine the average monthly costs for the past 3 months. Create an Amazon CloudWatch alarm for total estimated charges. Specify a cost threshold that is higher than the costs that Cost Explorer determined. Add a notification to alert the operations team if the alarm threshold is breached. C. Use AWS Cost Anomaly Detection to create a cost monitor that has a monitor type of linked account. Create a subscription to send daily AWS cost summaries to the operations team. Specify a threshold for cost variance. D. Use AWS Cost Anomaly Detection to create a cost monitor that has a monitor type of AWS services. Create a subscription to send daily AWS cost summaries to the operations team. Specify a threshold for cost variance. To abide by industry regulations, a solutions architect must design a solution that will store a company's critical data in multiple public AWS regions, including in the United States, where the company's headquarters is located. The solutions architect is required to provide access to the data stored in AWS to the company's Global WAN network. The security team mandates that no traffic accessing this data should traverse the public internet. How should the solutions architect design a highly available solution that meets the requirements and is cost-effective? A. Establish AWS Direct Connect connections from the company headquarters to all AWS regions in use. Use the company WAN to send traffic over to the headquarters and then to the respective DX connection to access the data. B. Establish 2 AWS Direct Connect connections from the company headquarters to an AWS region. Use the company WAN to send traffic over a DX connection. Use interregion VPC peering to access the data in other AWS regions. C. Establish 2 AWS Direct Connect connections from the company headquarters to an AWS region. Use the company WAN to send traffic over a DX connection. Use an AWS Transit VPC solution to access data in other AWS regions. D. Establish 2 AWS Direct Connect connections from the company headquarters to an AWS region. Use the company WAN to send traffic over a DX connection. Use Direct Connect Gateway to access data in other AWS regions. A company uses AWS organizations to manage its development environment. Each development team at the company has its own AWS account. Each account has a single VPC and CIDR blocks that do not overlap. The company has an Amazon Aurora DB cluster in a shared services account. All the development teams need to work with live data from the DB cluster. Which solution will provide the required connectivity to the DB cluster with the least operational overhead? A. Create an AWS Resource Access Manager, AWS RAM, resource share, for the DB cluster. Share the DB cluster with all the development accounts. B. Create a transit gateway in the shared services account. Create an AWS Resource Access Manager, AWS RAM, resource share for the transit gateway. Share the transit gateway with all the development accounts. Instruct the developers to accept the resource share. Configure networking. C. Create an application load balancer, ALB, that points to the IP address of the DB cluster. Create an AWS private link endpoint service that uses the ALB. Add permissions to allow each development account to connect to the endpoint service. D. Create an AWS site-to-site VPN connection in the shared services account. Configure networking. Use AWS Marketplace VPN software in each development account to connect to the site-to-site VPN connection. A public retail web application uses an application load balancer, ALB, in front of Amazon EC2 instances running across multiple availability zones, AZs, in a region backed by an Amazon RDS MySQL multi-AZ deployment. Target group health checks are configured to use HTTP and pointed at the product catalog page. Autoscaling is configured to maintain the web fleet size based on the ALB health check. Recently, the application experienced an outage. Autoscaling continuously replaced the instances during the outage. A subsequent investigation determined that the web server metrics were within the normal range, but the database tier was experiencing high load, resulting in severely elevated query response times. Which of the following changes together would remediate these issues while improving monitoring capabilities for the availability and functionality of the entire application stack for future growth? Choose 2. A. Configure read replicas for Amazon RDS MySQL and use the single reader endpoint in the web application to reduce the load on the back-end database tier. B. Configure the target group health check to point at a simple HTML page instead of a product catalog page, and the Amazon Route 53 health check against the product page to evaluate full application functionality. Configure Amazon CloudWatch alarms to notify administrators when the site fails. C. Configure the target group health check to use a TCP check of the Amazon EC2 web server and the Amazon Route 53 health check against the product page to evaluate full application functionality. Configure Amazon CloudWatch alarms to notify administrators when the site fails. D. Configure an Amazon CloudWatch alarm for Amazon RDS with an action to recover a high-load, impaired RDS instance in the database tier. E. Configure an Amazon ElastiCache cluster and place it between the web application and RDS MySQL instances to reduce the load on the backend database tier. A medical company is running a REST API on a set of Amazon EC2 instances. The EC2 instances run in an autoscaling group behind an application load balancer, ALB. The ALB runs in 3 public subnets, and the EC2 instances run in 3 private subnets. The company has deployed an Amazon CloudFront distribution that has the ALB as the only origin. Which solution should a solutions architect recommend to enhance the origin security? A. Store a random string in AWS Secrets Manager. Create an AWS Lambda function for automatic secret rotation. Configure CloudFront to inject the random string as a custom HTTP header for the origin request. Create an AWS WAF Web ACL rule with a string match rule for the custom header. Associate the Web ACL with the ALB. B. Create an AWS WAF Web ACL rule with an IP match condition of the CloudFront service IP address ranges. Associate the Web ACL with the AL. Move the ALB into the 3 private subnets. C. Store a random string in AWS Systems Manager Parameter Store. Configure Parameter Store automatic rotation for the string. Configure CloudFront to inject the random string as a custom HTTP header for the origin request. Inspect the value of the custom HTTP header and block access in the ALB. D. Configure AWS Shield Advanced. Create a security group policy to allow connections from CloudFront service IP address ranges. Add the policy to AWS Shield Advanced and attach the policy to the ALB. A company needs to architect a hybrid DNS solution. This solution will use an Amazon Route 53 private hosted zone for the domain cloud.example.com for the resources stored within VPCs. The company has the following DNS resolution requirements. On-premises systems should be able to resolve and connect to cloud.example.com. All VPCs should be able to resolve cloud.example.com. There is already an AWS Direct Connect connection between the on-premises corporate network and AWS Transit Gateway. A. Associate the private hosted zone to all the VPCs. Create a Route 53 inbound resolver in the Shared Services VPC. Attach all VPCs to the Transit Gateway and create forwarding rules in the on-premises DNS server for cloud.example.com that point to the inbound resolver. B. Associate the private hosted zone to all the VPCs. Deploy an Amazon EC2 conditional forwarder in the Shared Services VPC. Attach all VPCs to the Transit Gateway and create forwarding rules in the on-premises DNS server for cloud.example.com that point to the conditional forwarder. C. Associate the private hosted zone to the Shared Services VP. Create a Route 53 outbound resolver in the Shared Services VP. Attach all VPCs to the Transit Gateway and create forwarding rules in the on-premises DNS server for cloud.example.com that point to the outbound resolver. D. Associate the private hosted zone to the Shared Services VPC. create a Route 53 inbound resolver in the Shared Services VPC. Attach the Shared Services VPC to the Transit Gateway and create forwarding rules in the on-premises DNS server for cloud.example.com that point to the inbound resolver. A solutions architect wants to make sure that only AWS users or roles with suitable permissions can access a new Amazon API gateway endpoint. The solutions architect wants an end-to-end view of each request to analyze the latency of the request and create service maps. How can the solutions architect design the API gateway access control and perform request inspections? A. For the API gateway method, set the authorization to AWS_IAM. Then, give the IAM user or role execute API. Invoke permission on the REST API resource. Enable the API caller to sign requests with AWS signature when accessing the endpoint. Use AWS X-Ray to trace and analyze user requests to API gateway. B. For the API gateway resource, set CoreS to enabled and only return the company's domain in access control allow origin headers. Then, give the IAM user or role execute API. Invoke permission on the REST API resource. Use Amazon CloudWatch to trace and analyze user requests to API gateway. C. Create an AWS Lambda function as the custom authorizer. Ask the API client to pass the key and secret when making the call, and then use Lambda to validate the key-secret pair against the IAM system. Use AWS X-Ray to trace and analyze user requests to API gateway. D. Create a client certificate for API gateway. Distribute the certificate to the AWS users and roles that need to access the endpoint. Enable the API caller to pass the client certificate when accessing the endpoint. Use Amazon CloudWatch to trace and analyze user requests to API gateway. A company is migrating mobile banking applications to run on Amazon EC2 instances in a VPC. Backend service applications run in an on-premises data center. The data center has an AWS Direct Connect connection into AWS. The applications that run in the VPC need to resolve DNS requests to an on-premises Active Directory domain that runs in the data center. Which solution will meet these requirements with the least administrative overhead? A. Provision a set of EC2 instances across two availability zones in the VPC as caching DNS servers to resolve DNS queries from the application servers within the VPC. B. Provision an Amazon Route 53 private hosted zone. Configure NS records that point to on-premises DNS servers. C. Create DNS endpoints by using Amazon Route 53 resolver. Add conditional forwarding rules to resolve DNS namespaces between the on-premises data center and the VPC. D. Provision a new Active Directory domain controller in the VPC with a bi-directional trust between this new domain and the on-premises Active Directory domain. A company runs its sales reporting application in an AWS region in the United States. The application uses an Amazon API Gateway Regional API and AWS Lambda functions to generate on-demand reports from data in an Amazon RDS from MySQL database. The front end of the application is hosted on Amazon S3 and is accessed by users through an Amazon CloudFront distribution. The company is using Amazon Route 53 as the DNS service for the domain. Route 53 is configured with a simple routing policy to route traffic to the API Gateway API. In the next 6 months, the company plans to expand operations to Europe. More than 90% of the database traffic is read-only traffic. The company has already deployed an API, Gateway, API, and Lambda functions in the new region. A solutions architect must design a solution that minimizes latency for users who download reports. Which solution will meet these requirements? A. Use an AWS Database Migration Service, AWS DMS, task with full load to replicate the primary database in the original region to the database in the new region. Change the Route 53 record to latency-based routing to connect to the API Gateway API. B. Use an AWS Database Migration Service, AWS DMS task with full load plus change data capture, CDC, to replicate the primary database in the original region to the database in the new region. Change the Route 53 record to geolocation routing to connect to the API Gateway API. C. Configure a cross-region read replica for the RDS database in the new region. Change the Route 53 record to latency-based routing to connect to the API Gateway API. D. Configure a cross-region read replica for the RDS database in the new region. Change the Route 53 record to geolocation routing to connect to the API Gateway API. A solutions architect needs to migrate an on-premises legacy application to AWS. The application runs on 2 servers behind a load balancer. The application requires a license file that is associated with the MAC address of the server's network adapter. It takes the software vendor 12 hours to send new license files. The application also uses configuration files with a static IP address to access a database server. Host names are not supported. Given these requirements, which combination of steps should be taken to implement highly available architecture for the application servers in AWS? Choose 2. A. Create a pool of ENIs. Request license files from the vendor for the pool, and store the license files in Amazon S3. Create a Bootstrap automation script to download a license file and attach the corresponding ENI to an Amazon EC2 instance. B. Create a pool of ENIs. Request license files from the vendor for the pool. Store the license files on an Amazon EC2 instance. Create an AMI from the instance and use this AMI for all future EC2 instances. C. Create a Bootstrap automation script to request a new license file from the vendor. When the response is received, apply the license file to an Amazon EC2 instance. D. Edit the Bootstrap automation script to read the database server IP address from the AWS Systems Manager parameter store and inject the value into the local configuration files. E. Edit an Amazon EC2 instance to include the database server IP address in the configuration files and recreate the AMI to use for all future EC2 stances. A company is deploying a third-party firewall appliance solution from AWS Marketplace to monitor and protect traffic that leaves the company's AWS environments. The company wants to deploy this appliance into a shared services VPC and route all outbound internet-bound traffic through the appliances. A solutions architect needs to recommend a deployment method that prioritizes reliability and minimizes failover time between firewall appliances within a single AWS region. The company has set up routing from the shared services VPC to other VPCs. Which steps should the solutions architect recommend to meet these requirements? Choose 3. A. Deploy 2 firewall appliances into the shared services VPC, each in a separate availability zone. B. Create a new network load balancer in the shared services VPC. Create a new target group and attach it to the new network load balancer. Add each of the firewall appliance instances to the target group. C. Create a new gateway load balancer in the shared services VP. Create a new target group and attach it to the new gateway load balancer. Add each of the firewall appliance instances to the target group. D. Create a VPC interface endpoint. Add a route to the route table in the shared services VPC. Designate the new endpoint as the next hop for traffic that enters the shared services VPC from other VPCs. E. Deploy 2 firewall appliances into the shared services VPC, each in the same availability zone. F. Create a VPC gateway load balancer endpoint. Add a route to the route table in the shared services VPC. Designate the new endpoint as the next hop for traffic that enters the shared services VPC from other VPCs. A company that provides image storage services wants to deploy a customer-facing solution to AWS. Millions of individual customers will use the solution. The solution will receive batches of large image files, resize the files, and store the files in an Amazon S3 bucket for up to 6 months. The solution must handle significant variance in demand. The solution must also be reliable at enterprise scale and have the ability to rerun processing jobs in the event of failure. Which solution will meet these requirements most cost-effectively? A. Use AWS step functions to process the S3 event that occurs when a user stores an image. Run an AWS Lambda function that resizes the image in place and replaces the original file in the S3 bucket. Create an S3 lifecycle expiration policy to expire all stored images after 6 months. B. Use Amazon Event Bridge to process the S3 event that occurs when a user uploads an image. Run an AWS Lambda function that resizes the image in place and replaces the original file in the S3 bucket. Create an S3 lifecycle expiration policy to expire all stored images after 6 months. C. Use S3 event notifications to invoke an AWS Lambda function when a user stores an image. Use the Lambda function to resize the image in place and to store the original file in the S3 bucket. Create an S3 lifecycle policy to move all stored images to S3 Standard Infrequent Access, S3 Standard IA, after 6 months. A. Use Amazon Simple Queue Service, Amazon SQS, to process the S3 event that occurs when a user stores an image. Run an AWS Lambda function that resizes the image and stores the resized file in an S3 bucket that uses S3 Standard Infrequent Access, S3 Standard IA. Create an S3 lifecycle policy to move all stored images to S3 Glacier Deep Archive after 6 months. A company has introduced a new policy that allows employees to work remotely from their homes if they connect by using a VPN. The company is hosting internal applications with VPCs in multiple AWS accounts. Currently, the applications are accessible from the company's on-premises office network through an AWS site-to-site VPN connection. The VPC in the company's main AWS account has peering connections established with VPCs in other AWS accounts. A solutions architect must design a scalable AWS client VPN solution for employees to use while they work from home. What is the most cost-effective solution that meets these requirements? A. Create a client VPN endpoint in each AWS account. Configure required routing that allows access to internal applications. B. Create a client VPN endpoint in the main AWS account. Configure required routing that allows access to internal applications. C. Create a client VPN endpoint in the main AWS account. Provision a transit gateway that is connected to each AWS account. Configure required routing that allows access to internal applications. D. Create a client VPN endpoint in the main AWS account. Establish connectivity between the client VPN endpoint and the AWS site-to-site VPN. A company is using AWS organizations with a multi-account architecture. The company's current security configuration for the account architecture includes SCPs, resource-based policies, identity-based policies, trust policies, and session policies. A solutions architect needs to allow an IAM user in account A to assume a role in account B. Which combination of steps must the solutions architect take to meet this requirement? Choose 3. A. Configure the SCP for account A to allow the action. B. Configure the resource-based policies to allow the action. C. Configure the identity-based policy on the user in account A to allow the action. D. Configure the identity-based policy on the user in account B to allow the action. E. Configure the trust policy on the target role in account B to allow the action. F. Configure the session policy to allow the action and to be passed programmatically by the getSessionToken API operation. A company is running a 3-tier web application in an on-premises data center. The front end is served by an Apache web server. The middle tier is a monolithic Java application, and the storage tier is a PostgreSQL database. During a recent marketing promotion, customers could not place orders through the application because the application crashed. An analysis showed that all 3 tiers were overloaded. The application became unresponsive, and the database reached its capacity limit because of red operations. The company already has several similar promotions scheduled in the near future. A solutions architect must develop a plan for migration to AWS to resolve these issues. The solution must maximize scalability and must minimize operational effort. Which combination of steps will meet these requirements? Choose 3. A. Refactor the front end so that static assets can be hosted on Amazon S3. Use Amazon CloudFront to serve the front end to customers. Connect the front end to the Java application. B. Rehost the Apache web server of the front end on Amazon EC2 instances that are in an autoscaling group. Use a load balancer in front of the autoscaling group. Use Amazon Elastic File System, Amazon EFS, to host the static assets that the Apache web server needs. C. Rehost the Java application in an AWS Elastic Beanstalk environment that includes autoscaling. D. Refactor the Java application. Develop a Docker container to run the Java application. Use AWS Fargate to host the container. E. Use AWS Database Migration Service, AWS DMS, to re-platform the PostgreSQL database to an Amazon Aurora PostgreSQL database. Use Aurora autoscaling for read replicas. F. Rehost the PostgreSQL database on an Amazon EC2 instance that has twice as much memory as the on-premises server. A company uses a service to collect metadata from applications that the company hosts on premises. Consumer devices such as TVs and internet radios access the applications. Many older devices do not support certain HTTP headers and exhibit errors when these headers are present in responses. The company has configured an on-premises load balancer to remove the unsupported headers from responses sent to older devices, which the company identified by the user agent headers. The company wants to migrate the service to AWS, adopt serverless technologies, and retain the ability to support the older devices. The company has already migrated the applications into a set of AWS Lambda functions. Which solution will meet these requirements? A. Create an Amazon CloudFront distribution for the metadata service. Create an application load balancer. ALB. Configure the CloudFront distribution to forward requests to the ALB. Configure the ALB to invoke the correct Lambda function for each type of request. Create a CloudFront function to remove the problematic headers based on the value of the user agent header. B. Create an Amazon API Gateway REST API for the metadata service. Configure API Gateway to invoke the correct Lambda function for each type of request. Modify the default gateway responses to remove the problematic headers based on the value of the user agent header. C. Create an Amazon API Gateway HTTP API for the metadata service. Configure API Gateway to invoke the correct Lambda function for each type of request. Create a response mapping template to remove the problematic headers based on the value of the user agent. Associate the response data mapping with the HTTP API. D. Create an Amazon CloudFront distribution for the metadata service. Create an application load balancer. ALB. Configure the CloudFront distribution to forward requests to the ALB. Configure the ALB to invoke the correct Lambda function for each type of request. Create a Lambda at edge function that will remove the problematic headers in response to viewer requests based on the value of the user agent header. A company is deploying a new cluster for big data analytics on AWS. The cluster will run across many Linux Amazon EC2 instances that are spread across multiple availability zones. All of the nodes in the cluster must have read and write access to common underlying file storage. The file storage must be highly available, must be resilient, must be compatible with the Portable Operating System Interface (POSIX), and must accommodate high levels of throughput. Which storage solution will meet these requirements? A. Provision an AWS Storage Gateway File Gateway (NFS) file share that is attached to an Amazon S3 bucket. Mount the NFS file share on each EC2 instance in the cluster. B. Provision a new Amazon Elastic File System Amazon EFS file system that uses general-purpose performance mode. Mount the EFS file system on each EC2 instance in the cluster. C. Provision a new Amazon Elastic Block Store Amazon EBS volume that uses the IO2 volume type. Attach the EBS volume to all of the EC2 instances in the cluster. D. Provision a new Amazon Elastic File System Amazon EFS file system that uses Max I/O performance mode. Mount the EFS file system on each EC2 instance in the cluster. A company is hosting a critical application on a single Amazon EC2 instance. The application uses an Amazon ElastiCache for Redis single-node cluster for an in-memory data store. The application uses an Amazon RDS for MariaDB DB instance for a relational database. For the application to function, each piece of the infrastructure must be healthy and must be in an active state. A solutions architect needs to improve the application's architecture so that the infrastructure can automatically recover from failure with the least possible downtime. Which combination of steps will meet these requirements? Choose 3. A. Use an elastic load balancer to distribute traffic across multiple EC2 instances. Ensure that the EC2 instances are part of an auto-scaling group that has a minimum capacity of 2 instances. B. Use an elastic load balancer to distribute traffic across multiple EC2 instances. Ensure that the EC2 instances are configured in unlimited mode. C. Modify the DB instance to create a read replica in the same availability zone. Promote the read replica to be the primary DB instance in failure scenarios. D. Modify the DB instance to create a multi-AZ deployment that extends across 2 availability zones. E. Create a replication group for the ElastiCache for Redis cluster. Configure the cluster to use an autoscaling group that has a minimum capacity of 2 instances. F. Create a replication group for the ElastiCache for Redis cluster. Enable multi-AZ on the cluster. A flood monitoring agency has deployed more than 10,000 water level monitoring sensors. Sensors send continuous data updates, and each update is less than 1 megabyte in size. The agency has a fleet of on-premises application servers. These servers receive updates from the sensors, convert the raw data into a human-readable format, and write the results to an on-premises relational database server. Data analysts then use simple SQL queries to monitor the data. The agency wants to increase overall application availability and reduce the effort that is required to perform maintenance tasks. These maintenance tasks, which include updates and patches to the application servers, cause downtime. While an application server is down, data is lost from sensors because the remaining servers cannot handle the entire workload. The agency wants a solution that optimizes operational overhead and costs. A solutions architect recommends the use of AWS IoT Core to collect the sensor data. What else should the solutions architect recommend to meet these requirements? A. Send the sensor data to Amazon Kinesis Data Firehose. Use an AWS Lambda function to read the Kinesis Data Firehose data, convert it to .csv format, and insert it into an Amazon Aurora MySQL DB instance. Instruct the data analysts to query the data directly from the DB instance. B. Send the sensor data to Amazon Kinesis Data Firehose. Use an AWS Lambda function to read the Kinesis Data Firehose data, convert it to Apache Parquet format, and save it to an Amazon S3 bucket. Instruct the data analysts to query the data by using Amazon Athena. C. Send the sensor data to an Amazon Managed Service for Apache Flink, previously known as Amazon Kinesis Data Analytics, application to convert the data to .csv format and store it in an Amazon S3 bucket. Import the data into an Amazon Aurora MySQL DB instance. Instruct the data analysts to query the data directly from the DB instance. D. Send the sensor data to an Amazon Managed Service for Apache Flink, previously known as Amazon Kinesis Data Analytics, application to convert the data to Apache Parquet format and store it in an Amazon S3 bucket. Instruct the data analysts to query the data by using Amazon Athena. A software-as-a-service SaaS-based company provides a case management solution to customers, a 3-part of the solution. The company uses a standalone Simple Mail Transfer Protocol (SMTP) server to send email messages from an application. The application also stores an email template for acknowledgement email messages that populate customer data before the application sends the email message to the customer. The company plans to migrate this messaging functionality to the AWS cloud and needs to minimize operational overhead. Which solution will meet these requirements most cost-effectively? A. Set up an SMTP server on Amazon EC2 instances by using an AMI from the AWS Marketplace. Store the email template in an Amazon S3 bucket. Create an AWS Lambda function to retrieve the template from the S3 bucket and to merge the customer data from the application with the template. Use an SDK in the Lambda function to send the email message. B. Set up Amazon Simple Email Service, Amazon SES, to send email messages. Store the email template in an Amazon S3 bucket. Create an AWS Lambda function to retrieve the template from the S3 bucket and to merge the customer data from the application with the template. Use an SDK in the Lambda function to send the email message. C. Set up an SMTP server on Amazon EC2 instances by using an AMI from the AWS Marketplace. Store the email template in Amazon Simple Email Service, Amazon SES, with parameters for the customer data. Create an AWS Lambda function to call the SES template and to pass customer data to replace the parameters. Use the AWS Marketplace SMTP server to send the email message. D. Set up Amazon Simple Email Service, Amazon SES, to send email messages. Store the email template on Amazon SES with parameters for the customer data. Create an AWS Lambda function to call the Send Templated Email API operation and to pass customer data to replace the parameters and the email destination. A company has 10 accounts that are part of an organization in AWS organizations. AWS config is configured in each account. All accounts belong to either the prod OU or the non-prod OU. The company has set up an Amazon Event Bridge rule in each AWS account to notify an Amazon Simple Notification Service, Amazon SNS topic, when an Amazon EC2 security group inbound rule is created with 0.0.0.0.0/0 as the source. The company's security team is subscribed to the SNS topic. For all accounts in the non-prod OU, the security team needs to remove the ability to create a security group inbound rule that includes 0.0.0.0/0/0 as the source. Which solution will meet this requirement with the least operational overhead? A. Modify the Event Bridge rule to invoke an AWS Lambda function to remove the security group inbound rule and to publish to the SNS topic. Deploy the updated rule to the non-prod OU. B. Add the VPCSG open only to authorized ports AWS config managed rule to the non-prod OU. C. Configure an SCP to allow the EC2 authorized security group ingress action when the value of the AWS source IP condition key is not 0.0.0.0/0. Apply the SCP to the non-prod OU. D. Configure an SCP to deny the EC2 authorized security group ingress action when the value of the AWS source IP condition key is 0.0.0.0/0. Apply the SCP to the non-prod OU. A company has a monolithic application that is critical to the company's business. The company hosts the application on an Amazon EC2 instance that runs Amazon Linux 2. The company's application team receives a directive from the legal department to back up the data from the instance's encrypted Amazon Elastic Block Store, Amazon EBS volume, to an Amazon S3 bucket. The application team does not have the administrative SSH key pair for the instance. The application must continue to serve the users. Which solution will meet these requirements? A. Attach a role to the instance with permission to write to Amazon S3. Use the AWS Systems Manager Session Manager option to gain access to the instance and run commands to copy data into Amazon S3. B. Create an image of the instance with the reboot option turned on. Launch a new EC2 instance from the image. Attach a role to the new instance with permission to write to Amazon S3. Run a command to copy data into Amazon S3. C. Take a snapshot of the EBS volume by using Amazon Data Lifecycle Manager, Amazon DLM. Copy the data to Amazon S3. D. Create an image of the instance. Launch a new EC2 instance from the image. Attach a role to the new instance with permission to write to Amazon S3. Run a command to copy data into Amazon S3. A company is running a traditional web application on Amazon EC2 instances. The company needs to refactor the application as microservices that run on containers. Separate versions of the application exist in two distinct environments: production and testing. Load for the application is variable, but the minimum load and the maximum load are known. A solutions architect needs to design the updated application with a serverless architecture that minimizes operational complexity. Which solution will meet these requirements most cost-effectively? A. Upload the container images to AWS Lambda as functions. Configure a concurrency limit for the associated Lambda functions to handle the expected peak load. Configure two separate Lambda integrations within Amazon API Gateway, one for production and one for testing. B. Upload the container images to Amazon Elastic Container Registry, Amazon ECR. Configure two auto-scaled Amazon Elastic Container Service, Amazon ECS, clusters with the Fargate launch type to handle the expected load. Deploy tasks from the ECR images. Configure two separate application load balancers to direct traffic to the ECS clusters. C. Upload the container images to Amazon Elastic Container Registry, Amazon ECR. Configure two auto-scaled Amazon Elastic Kubernetes Service, Amazon EKS, clusters with the Fargate launch type to handle the expected load. Deploy tasks from the ECR images. Configure two separate application load balancers to direct traffic to the EKS clusters. D. Upload the container images to AWS Elastic Beanstalk. In Elastic Beanstalk, create separate environments and deployments for production and testing. Configure two separate application load balancers to direct traffic to the Elastic Beanstalk deployments. A solutions architect has implemented a SAML 2.0 federated identity solution with their company's on-premises identity provider, IDP, to authenticate users' access to the AWS environment. When the solutions architect tests authentication through the federated identity web portal, access to the AWS environment is granted. However, when test users attempt to authenticate through the federated identity web portal, they are not able to access the AWS environment. Which items should the solutions architect check to ensure identity federation is properly configured? Choose 3. A. The IAM user's permissions policy has allowed the use of SAML federation for that user. B. The IAM roles created for the federated users or federated groups trust policy have set the SAML provider as the principal. B. Test users are not in the AWS federated users group in the company's IDP. C. The web portal calls the AWS STS assume role with SAML API with the ARN of the SAML provider, the ARN of the IAM role, and the SAML assertion from IDP. D. The on-premises IDP's DNS hostname is reachable from the AWS environment VPCs. E. The company's IDP defines SAML assertions that properly map users or groups in the company to IAM roles with appropriate permissions. A company hosts a Git repository in an on-premises data center. The company uses webhooks to invoke functionality that runs in the AWS cloud. The company hosts the webhook logic on a set of Amazon EC2 instances in an auto-scaling group that the company set as a target for an application load balancer, ALB. The Git server calls the ALB for the configured webhooks. The company wants to move the solution to a serverless architecture. Which solution will meet these requirements with the least operational overhead? A. For each webhook, create and configure an AWS Lambda function URL. Update the Git servers to call the individual Lambda function URLs. B. Create an Amazon API Gateway HTTP API. Implement each webhook logic in a separate AWS Lambda function. Update the Git servers to call the API Gateway endpoint. C. Deploy the webhook logic to AWS App Runner. Create an ALB and set App Runner as the target. Update the Git servers to call the ALB endpoint. D. Containerize the webhook logic. Create an Amazon Elastic Container Service Amazon ECS cluster and run the webhook logic in AWS Fargate. Create an Amazon API Gateway REST API and set Fargate as the target. Update the Git servers to call the API Gateway endpoint. A company uses AWS organizations. The company runs 2 firewall appliances in a centralized networking account. Each firewall appliance runs on a manually configured, highly available Amazon EC2 instance. A transit gateway connects the VPC from the centralized networking account to VPCs of member accounts. Each firewall appliance uses a static private IP address that is then used to route traffic from the member accounts to the Internet. During a recent incident, a badly configured script initiated the termination of both firewall appliances. During the rebuild of the firewall appliances, the company wrote a new script to configure the firewall appliances at startup. The company wants to modernize the deployment of the firewall appliances. The firewall appliances need the ability to scale horizontally to handle increased traffic when the network expands. The company must continue to use the firewall appliances to comply with company policy. The provider of the firewall appliances has confirmed that the latest version of the firewall code will work with all AWS services. Which combination of steps should the solutions architect recommend to meet these requirements most cost-effectively? Choose 3. A. Deploy a gateway load balancer in the centralized networking account. Set up an endpoint service that uses AWS Private Link. B. Deploy a network load balancer in the centralized networking account. Set up an endpoint service that uses AWS Private Link. C. Create an auto-scaling group and a launch template that uses the new script as user data to configure the firewall appliances. Create a target group that uses the instance target type. D. Create an auto-scaling group. Configure an AWS Launch Wizard deployment that uses the new script as user data to configure the firewall appliances. Create a target group that uses the IP target type. E. Create VPC endpoints in each member account. Update the route tables to point to the VPC endpoints. F. Create VPC endpoints in the centralized networking account. Update the route tables in each member account to point to the VPC endpoints. A company has multiple lines of business, LOBs, that roll up to the parent company. The company has asked its solutions architect to develop a solution with the following requirements. Produce a single AWS invoice for all of the AWS accounts used by its LOBs. The costs for each LOB account should be broken out on the invoice. Provide the ability to restrict services and features in the LOB accounts, as defined by the company's governance policy. Each LOB account should be delegated full administrator permissions, regardless of the governance policy. Which combination of steps should the solutions architect take to meet these requirements? Choose 2. A. Use AWS organizations to create an organization in the parent account for each LOB. Then invite each LOB account to the appropriate organization. B. Use AWS organizations to create a single organization in the parent account. Then invite each LOB's AWS account to join the organization. C. Implement service quotas to define the services and features that are permitted and apply the quotas to each LOB as appropriate. D. Create an SCP that allows only approved services and features, then apply the policy to the LOB accounts. E. Enable consolidated billing in the parent account's billing console and link the LOB accounts. A company solutions architect needs to provide secure remote desktop connectivity to users for Amazon EC2 Windows instances that are hosted in a VPC. The solution must integrate centralized user management with the company's on-premises Active Directory. Connectivity to the VPC is through the Internet. The company has hardware that can be used to establish an AWS site-to-site VPN connection. Which solution will meet these requirements most cost-effectively? A. Deploy a managed Active Directory by using AWS Directory Service for Microsoft Active Directory. Establish a trust with the on-premises Active Directory. Deploy an EC2 instance as a bastion host in the VPC. Ensure that the EC2 instance is joined to the domain. Use the bastion host to access the target instances through RDP. B. Configure AWS IAM Identity Center, AWS Single Sign-On, to integrate with the on-premises Active Directory by using the AWS Directory Service for Microsoft Active Directory AD connector. Configure permission sets against user groups for access to AWS Systems Manager. Use Systems Manager Fleet Manager to access the target instances through RDP. C. Implement a VPN between the on-premises environment and the target VP. Ensure that the target instances are joined to the on-premises Active Directory domain over the VPN connection. Configure RDP access through the VPN. Connect from the company's network to the target instances. D. Deploy a managed Active Directory by using AWS Directory Service for Microsoft Active Directory. Establish a trust with the on-premises Active Directory. Deploy a remote desktop gateway on AWS by using an AWS Quick Start. Ensure that the remote desktop gateway is joined to the domain. Use the remote desktop gateway to access the target instances through RDP. A software company needs to create short-lived test environments to test pull requests as part of its development process. Each test environment consists of a single Amazon EC2 instance that is in an auto-scaling group. The test environments must be able to communicate with a central server to report test results. The central server is located in an on-premises data center. A solutions architect must implement a solution so that the company can create and delete test environments without any manual intervention. The company has created a transit gateway with a VPN attachment to the on-premises network. Which solution will meet these requirements with the least operational overhead? A. Create an AWS CloudFormation template that contains a transit gateway attachment and related routing configurations. Create a CloudFormation stack set that includes this template. Use CloudFormation stack sets to deploy a new stack for each VPC in the account. Deploy a new VPC for each test environment. B. Create a single VPC for the test environments. Include a transit gateway attachment and related routing configurations. Use AWS CloudFormation to deploy all test environments into the VPC. C. Create a new OU in AWS organizations for testing. Create an AWS CloudFormation template that contains a VPC, necessary networking resources, a transit gateway attachment, and related routing configurations. Create a CloudFormation stack set that includes this template. Use CloudFormation stack sets for deployments into each account under the testing OU. Create a new account for each test environment. D. Convert the test environment EC2 instances into Docker images. Use AWS CloudFormation to configure an Amazon Elastic Kubernetes Service (Amazon EKS) cluster in a new VPC. Create a transit gateway attachment and create related routing configurations. Use Kubernetes to manage the deployment and lifecycle of the test environments. A solutions architect is planning to migrate critical Microsoft SQL Server databases to AWS. Because the databases are legacy systems, the solutions architect will move the databases to a modern data architecture. The solutions architect must migrate the databases with near-zero downtime. Which solution will meet these requirements? A. Use AWS Application Migration Service and the AWS Schema Conversion Tool, AWS SCT. Perform an in-place upgrade before the migration. Export the migrated data to Amazon Aurora Serverless after cutover. Repoint the applications to Amazon Aurora. B. Use AWS Database Migration Service, AWS DMS, to rehost the database. Set Amazon S3 as a target. Set up Change Data Capture, CDC replication. When the source and destination are fully synchronized, load the data from Amazon S3 into an Amazon RDS for Microsoft SQL Server DB instance. C. Use native database high availability tools. Connect the source system to an Amazon RDS for Microsoft SQL Server DB instance. Configure replication accordingly. When data replication is finished, transition the workload to an Amazon RDS for Microsoft SQL Server DB instance. D. Use AWS Application Migration Service. Rehost the database server on Amazon EC2. When data replication is finished, detach the database and move the database to an Amazon RDS for Microsoft SQL Server DB instance. Reattach the database and then cut overall networking. A company runs a highly available data collection application on Amazon EC2 in the EU North 1 region. The application collects data from end-user devices and writes records to an Amazon Kinesis data stream and a set of AWS Lambda functions that process the records. The company persists the output of the record processing to an Amazon S3 bucket in EU North 1. The company uses the data in the S3 bucket as a data source for Amazon Athena. The company wants to increase its global presence. A solutions architect must launch the data collection capabilities in the SAT East 1 and AP Northeast 1 regions. The solutions architect deploys the application, the Kinesis data stream, and the Lambda functions in the two new regions. The solutions architect keeps the S3 bucket in EU North 1 to meet a requirement to centralize the data analysis. During testing of the new setup, the solutions architect notices a significant lag on the arrival of data from the new regions to the S3 bucket. Which solution will improve this lag time the most? A. In each of the two new regions, set up the Lambda functions to run in a VPC. Set up an S3 gateway endpoint in that VPC. B. Turn on S3 transfer acceleration on the S3 bucket in EU North 1. Change the application to use the new S3 accelerated endpoint when the application uploads data to the S3 bucket. C. Create an S3 bucket in each of the two new regions. Set the application in each new region to upload to its respective S3 bucket. Set up S3 cross-region replication to replicate data to the S3 bucket in EU North 1. A. Increase the memory requirements of the Lambda functions to ensure that they have multiple cores available. Use the multi-part upload feature when the application uploads data to Amazon S3 from Lambda. A software as a service, SaaS provider, exposes APIs through an application load balancer, ALB. The ALB connects to an Amazon Elastic Kubernetes service, Amazon EKS cluster, that is deployed in the US East 1 region. The exposed APIs contain usage of a few non-standard REST methods: link, unlink, lock, and unlock. Users outside the United States are reporting long and inconsistent response times for these APIs. A solutions architect needs to resolve this problem with a solution that minimizes operational overhead. Which solution meets these requirements? A. Add an Amazon CloudFront distribution. Configure the ALB as the origin. B. Add an Amazon API Gateway Edge optimized API endpoint to expose the APIs. Configure the ALB as the target. C. Add an accelerator in AWS Global Accelerator. Configure the ALB as the origin. D. Deploy the APIs to 2 additional AWS regions, EU West 1 and AP Southeast 2. Add latency-based routing records in Amazon Route 53. A company uses AWS organizations with a single OU named production to manage multiple accounts. All accounts are members of the production OU. Administrators use deny list SCPs in the root of the organization to manage access to restricted services. The company recently acquired a new business unit and invited the new unit's existing AWS account to the organization. Once onboarded, the administrators of the new business unit discovered that they are not able to update existing AWS config rules to meet the company's policies. Which option will allow administrators to make changes and continue to enforce the current policies without introducing additional long-term maintenance? A. Remove the organization's root SCPs that limit access to AWS config. Create AWS Service Catalog products for the company's standard AWS config rules and deploy them throughout the organization, including the new account. B. Create a temporary OU named Onboarding for the new account. Apply an SCP to the onboarding OU to allow AWS config actions. Move the new account to the production OU when adjustments to AWS config are complete. C. Convert the organization's root SCPs from deny list SCPs to allow list SCPs to allow the required services only. Temporarily apply an SCP to the organization's root that allows AWS config actions for principals only in the new account. D. Create a temporary OU named Onboarding for the new account. Apply an SCP to the onboarding OU to allow AWS config actions. Move the organization's root SCP to the production OU. Move the new account to the production OU when adjustments to AWS config are complete. A software as a service SaaS company uses AWS to host a service that is powered by AWS Private Link. The service consists of proprietary software that runs on 3 Amazon EC2 instances behind a network load balancer, NLB. The instances are in private subnets in multiple availability zones in the EU West 2 region. All the company's customers are in EU West 2. However, the company now acquires a new customer in the US East 1 region. The company creates a new VPC and new subnets in US East 1. The company establishes inter-region VPC peering between the VPCs in the 2 regions. The company wants to give the new customer access to the SaaS service, but the company does not want to immediately deploy new EC2 resources in US East 1. Which solution will meet these requirements? A. Configure a private link endpoint service in US East 1 to use the existing NLB that is in EU West 2. Grant specific AWS accounts access to connect to the SaaS service. B. Create an NLB in US East 1. Create an IP target group that uses the IP addresses of the company's instances in EU West 2 that host the SaaS service. Configure a private link endpoint service that uses the NLB that is in US East 1. Grant specific AWS accounts access to connect to the SaaS service. C. Create an application load balancer (ALB) in front of the EC2 instances in EU West 2. Create an NLB in US East 1. Associate the NLB that is in US East 1 with an ALB target group that uses the ALB that is in EU West 2. Configure a private link endpoint service that uses the NLB that is in US East 1. Grant specific AWS accounts access to connect to the SaaS service. D. Use AWS Resource Access Manager (AWS RAM) to share the EC2 instances that are in EU West 2. In US East 1, create an NLB and an instance target group that includes the shared EC2 instances from EU West 2. Configure a private link endpoint service that uses the NLB that is in US East 1. Grant specific AWS accounts access to connect to the SaaS service. A company uses a mobile app on AWS to run online contests. The company selects a winner at random at the end of each contest. The contests run for variable lengths of time. The company does not need to retain any data from a contest after the contest is finished. The company uses custom code that is hosted on Amazon EC2 instances to process the contest data and select a winner. The EC2 instances run behind an application load balancer and store contest entries on Amazon RDS-DB instances. The company must design a new architecture to reduce the cost of running the contests. Which solution will meet these requirements most cost-effectively? A. Migrate storage of the contest entries to Amazon DynamoDB. Create a DynamoDB accelerator (DAX) cluster. Rewrite the code to run as Amazon Elastic Container Service. Amazon ECS containers that use the Fargate launch type. At the end of the contest, delete the DynamoDB table. B. Migrate the storage of the contest entries to Amazon Redshift. Rewrite the code as AWS Lambda functions. At the end of the contest, delete the Redshift cluster. C. Add an Amazon Elastic cache for Redis cluster in front of the RDS-DB instances to cache the contest entries. Rewrite the code to run as Amazon Elastic Container Service. Amazon ECS containers that use the Fargate launch type. Set the Elastic Cache TTL attribute on each entry to expire each entry at the end of the contest. D. Migrate the storage of the contest entries to Amazon DynamoDB. Rewrite the code as AWS Lambda functions. Set the DynamoDB TTL attribute on each entry to expire each entry at the end of the contest. A company is creating a centralized logging service running on Amazon EC2 that will receive and analyze logs from hundreds of AWS accounts. AWS Private Link is being used to provide connectivity between the client services and the logging service. In each AWS account with a client, an interface endpoint has been created for the logging service and is available. The logging service running on EC2 instances with a network load balancer, NLB, are deployed in different subnets. The clients are unable to submit logs using the VPC endpoint. Which combination of steps should a solutions architect take to resolve this issue? Choose 2. A. Check that the NACL is attached to the logging service subnet to allow communications to and from the NLB subnets. Check that the NACL is attached to the NLB subnet to allow communications to and from the logging service subnets running on EC2 instances. B. Check that the NACL is attached to the logging service subnets to allow communications to and from the interface endpoint subnets. Check that the NACL is attached to the interface endpoint subnet to allow communications to and from the logging service subnets running on EC2 instances. C. Check the security group for the logging service running on the EC2 instances to ensure it allows ingress from the NLB subnets. D. Check the security group for the logging service running on EC2 instances to ensure it allows ingress from the clients. E. Check the security group for the NLB to ensure it allows ingress from the interface endpoint subnets. A security engineer determined that an existing application retrieves credentials to an Amazon RDS for MySQL database from an encrypted file in Amazon S3. For the next version of the application, the security engineer wants to implement the following application design changes to improve security. The database must use strong, randomly generated passwords stored in a secure AWS managed service. The application resources must be deployed through AWS CloudFormation. The application must rotate credentials for the database every 90 and NBSP days. A solutions architect will generate a CloudFormation template to deploy the application. A. Generate the database password as a secret resource using AWS Secrets Manager. Create an AWS Lambda function resource to rotate the database password. Specify a Secrets Manager rotation schedule resource to rotate the database password every 90 days. B. Generate the database password as a secure string parameter type using AWS Systems Manager Parameter Store. Create an AWS Lambda function resource to rotate the database password. Specify a parameter store rotation schedule resource to rotate the database password every 90 days. C. Generate the database password as a secret resource using AWS Secrets Manager. Create an AWS Lambda function resource to rotate the database password. Create an Amazon Event Bridge scheduled rule resource to trigger the Lambda function password rotation every 90 days. D. Generate the database password as a secure string parameter type using AWS Systems Manager Parameter Store. Specify an AWS AppSync data source resource to automatically rotate the database password every 90 days. A company is developing a new serverless API by using Amazon API Gateway and AWS Lambda. The company integrated the Lambda functions with API Gateway to use several shared libraries and custom classes. A solutions architect needs to simplify the deployment of the solution and optimize for code reuse. Which solution will meet these requirements? A. Deploy the shared libraries and custom classes into a Docker image. Store the image in an S3 bucket. Create a Lambda layer that uses the Docker image as the source. Deploy the API's Lambda functions as zip packages. Configure the packages to use the Lambda layer. B. Deploy the shared libraries and custom classes to a Docker image. Upload the image to Amazon Elastic Container Registry, Amazon ECR. Create a Lambda layer that uses the Docker image as the source. Deploy the API's Lambda functions as zip packages. Configure the packages to use the Lambda layer. C. Deploy the shared libraries and custom classes to a Docker container in Amazon Elastic Container Service, Amazon ECS, by using the AWS Fargate launch type. Deploy the API's Lambda functions as zip packages. Configure the packages to use the deployed container as a Lambda layer. D. Deploy the shared libraries, custom classes, and code for the API's Lambda functions to a Docker image. Upload the image to Amazon Elastic Container Registry, Amazon ECR. Configure the API's Lambda functions to use the Docker image as the deployment package. A company is running an event ticketing platform on AWS and wants to optimize the platform's cost-effectiveness. The platform is deployed on Amazon Elastic Kubernetes Service, Amazon EKS, with Amazon EC2, and is backed by an Amazon RDS for MySQL DB instance. The company is developing new application features to run on Amazon EKS with AWS Fargate. The platform experiences infrequent high peaks in demand. The surges in demand depend on event dates. Which solution will provide the most cost-effective setup for the platform? A. Purchase standard reserved instances for the EC2 instances that the EKS cluster uses in its baseline load. Scale the cluster with spot instances to handle peaks. Purchase 1 year all upfront reserved instances for the database to meet predicted peak load for the year. B. Purchase compute savings plans for the predicted median load of the EKS cluster. Scale the cluster with on-demand and capacity reservations based on event dates for peaks. Purchase 1 year, no upfront reserved instances for the database to meet the predicted base load. Temporarily scale out database read replicas during peaks. C. Purchase EC2 instance savings plans for the predicted baseload of the EKS cluster. Scale the cluster with spot instances to handle peaks. Purchase 1 year, all upfront reserved instances for the database to meet the predicted baseload. Temporarily scale up the DB instance manually during peaks. D. Purchase compute savings plans for the predicted baseload of the EKS cluster. Scale the cluster with spot instances to handle peaks. Purchase 1 year, all upfront reserved instances for the database to meet the predicted base load. Temporarily scale up the DB instance manually during peaks. A company is creating a solution that can move 400 employees into a remote working environment in the event of an unexpected disaster. The user desktops have a mix of Windows and Linux operating systems. Multiple types of software, such as web browsers and mail clients, are installed on each desktop. A solutions architect needs to implement a solution that can be integrated with the company's on-premises Active Directory to allow employees to use their existing identity credentials. The solution must provide multi-factor authentication, MFA, and must replicate the user experience from the existing desktops. Which solution will meet these requirements? A. Use Amazon Workspaces for the cloud desktop service. Set up a VPN connection to the on-premises network. Create an AD connector and connect to the on-premises Active Directory. Activate MFA for Amazon Workspaces by using the AWS Management Console. B. Use Amazon AppStream 2.0 as an application streaming service. Configure desktop view for the employees. Set up a VPN connection to the on-premises network. Set up Active Directory Federation Services, AD fluorine monosulfide, on-premises. Connect the VPC network to ADFS through the VPN connection. C. Use Amazon Workspaces for the cloud desktop service. Set up a VPN connection to the on-premises network. Create an AD connector and connect to the on-premises Active Directory. Configure a Radius server for MFA. D. Use Amazon AppStream 2.0 as an application streaming service. Set up Active Directory Federation Services on premises. Configure MFA to grant users access on AppStream 2.0. A company has an on-premises monitoring solution using a PostgreSQL database for persistence of events. The database is unable to scale due to heavy ingestion, and it frequently runs out of storage. The company wants to create a hybrid solution and has already set up a VPN connection between its network and AWS. The solution should include the following attributes: managed AWS services to minimize operational complexity, a buffer that automatically scales to match the throughput of data and requires no ongoing administration, a visualization tool to create dashboards to observe events in near real time, support for semi-structured JSON data and dynamic schemas. Which combination of components will enable the company to create a monitoring solution that will satisfy these requirements? Choose 2. A. Use Amazon Kinesis Data Firehose to buffer events. Create an AWS Lambda function to process and transform events. B. Create an Amazon Kinesis data stream to buffer events. Create an AWS Lambda function to process and transform events. C. Configure an Amazon Aurora PostgreSQL DB cluster to receive events. Use Amazon QuickSight to read from the database and create near real-time visualizations and dashboards. D. Configure Amazon Elasticsearch Service, Amazon ES, to receive events. Use the Kibana endpoint deployed with Amazon ES to create near real-time visualizations and dashboards. E. Configure an Amazon Neptune DB instance to receive events. Use Amazon QuickSight to read from the database and create near real-time visualizations and dashboards. A company has a project that is launching Amazon EC2 instances that are larger than required. The project's account cannot be part of the company's organization in AWS organizations due to policy restrictions to keep this activity outside of corporate IT. The company wants to allow only the launch of T3, small EC2, instances by developers in the project's account. These EC2 instances must be restricted to the US East 2 region. What should a solutions architect do to meet these requirements? A. Create a new developer account. Move all EC2 instances, users, and assets into US East 2. Add the account to the company's organization in AWS organizations. Enforce a tagging policy that denotes region affinity. B. Create an SCP that denies the launch of all EC2 instances except T3, small EC2 instances, in US East 2. Attach the SCP to the project's account. C. Create and purchase a T3, small EC2 reserved instance for each developer in US East 2. Assign each developer a specific EC2 instance with their name as the tag. D. Create an IAM policy that allows the launch of only T3, small EC2 instances in US East 2. Attach the policy to the roles and groups that the developers use in the project's account. A research company is running daily simulations in the AWS cloud to meet high demand. The simulations run on several hundred Amazon EC2 instances that are based on Amazon Linux 2. Occasionally, a simulation gets stuck and requires a cloud operations engineer to solve the problem by connecting to an EC2 instance through SSH. Company policy states that no EC2 instance can use the same SSH key and that all connections must be logged in AWS CloudTrail. How can a solutions architect meet these requirements? A. Launch new EC2 instances and generate an individual SSH key for each instance. Store the SSH key in AWS Secrets Manager. Create a new IAM policy and attach it to the engineer's IAM role with an allow statement for the get secret value action. Instruct the engineers to fetch the SSH key from Secrets Manager when they connect through any SSH client. B. Create an AWS Systems Manager document to run commands on EC2 instances to set a new unique SSH key. Create a new IAM policy and attach it to the engineer's IAM role with an allow statement to run Systems Manager documents. Instruct the engineers to run the document to set an SSH key and to connect through any SSH client. C. Launch new EC2 instances without setting up any SSH key for the instances. Set up EC2 Instance Connect on each instance. Create a new IAM policy and attach it to the engineer's IAM role with an allow statement for the send SSH public key action. Instruct the engineers to connect to the instance by using a browser-based SSH client from the EC2 console. D. Set up AWS Secrets Manager to store the EC2 SSH key. Create a new AWS Lambda function to create a new SSH key, and to call AWS Systems Manager Session Manager to set the SSH key on the EC2 instance. Configure Secrets Manager to use the Lambda function for automatic rotation once daily. Instruct the engineers to fetch the SSH key from Secrets Manager when they connect through any SSH client. A company is re-architecting its applications to run on AWS. The company's infrastructure includes multiple Amazon EC2 instances. The company's development team needs different levels of access. The company wants to implement a policy that requires all Windows EC2 instances to be joined to an Active Directory domain on AWS. The company also wants to implement enhanced security processes such as multi-factor authentication, MFA. The company wants to use managed AWS services wherever possible. Which solution will meet these requirements? A. Create an AWS directory service for Microsoft Active Directory implementation. Launch an Amazon Workspace. Connect to and use the workspace for domain security configuration tasks. B. Create an AWS directory service for Microsoft Active Directory implementation. Launch an EC2 instance. Connect to and use the EC2 instance for domain security configuration tasks. C. Create an AWS directory service, simple AD implementation. Launch an EC2 instance. Connect to and use the EC2 instance for domain security configuration tasks. D. Create an AWS directory service, simple AD implementation. Launch an Amazon Workspace. Connect to and use the workspace for domain security configuration tasks. A solutions architect is designing an AWS account structure for a company that consists of multiple teams. All the teams will work in the same AWS region. The company needs a VPC that is connected to the on-premises network. The company expects less than 50 megabits per second of total traffic to and from the on-premises network. Which combination of steps will meet these requirements most cost-effectively? Choose 2. A. Create an AWS CloudFormation template that provisions a VPC and the required subnets. Deploy the template to each AWS account. B. Create an AWS CloudFormation template that provisions a VPC and the required subnets. Deploy the template to a shared services account. Share the subnets by using AWS Resource Access Manager. C. Use AWS Transit Gateway along with an AWS site-to-site VPN for connectivity to the on-premises network. Share the Transit Gateway by using AWS Resource Access Manager. D. Use AWS site-to-site VPN for connectivity to the on-premises network. E. Use AWS Direct Connect for connectivity to the on-premises network. A large education company recently introduced Amazon Workspaces to provide access to internal applications across multiple universities. The company is storing user profiles on an Amazon FSx for Windows File Server file system. The file system is configured with a DNS alias and is connected to a self-managed Active Directory. As more users begin to use the workspaces, login time increases to unacceptable levels. An investigation reveals a degradation in performance of the file system. The company created the file system on HDD storage with a throughput of 16 Mbps. A solutions architect must improve the performance of the file system during a defined maintenance window. What should the solutions architect do to meet these requirements with the least administrative effort? A solutions architect is designing a solution to process events. The solution must have the ability to scale in and out based on the number of events that the solution receives. If a processing error occurs, the event must move into a separate queue for review. Which solution will meet these requirements? A. Send event details to an Amazon Simple Notification Service, Amazon SNS topic. Configure an AWS Lambda function as a subscriber to the SNS topic to process the events. Add an on-failure destination to the function. Set an Amazon Simple Queue service, Amazon SQS as the target. B. Publish events to an Amazon Simple Queue service, Amazon SQS. Create an Amazon EC2 auto-scaling group. Configure the auto-scaling group to scale in and out based on the approximate age of oldest message metric of the queue. Configure the application to write failed messages to a dead letter queue. C. Write events to an Amazon DynamoDB table. Configure a DynamoDB stream for the table. Configure the stream to invoke an AWS Lambda function. Configure the Lambda function to process the events. D. Publish events to an Amazon Event Beyond Event Bus. Create and run an application on an Amazon EC2 instance with an auto-scaling group that is behind an application load balancer, ALB. Set the ALB as the event bus target. Configure the event bus to retry events. Write messages to a dead letter queue if the application cannot process the messages. A company is building a software as a service (SaaS) solution on AWS. The company has deployed an Amazon API Gateway REST API with AWS Lambda integration in multiple AWS regions and in the same production account. The company offers tiered pricing that gives customers the ability to pay for the capacity to make a certain number of API calls per second. The premium tier offers up to 3,000 calls per second, and customers are identified by a unique API key. Several premium tier customers in various regions report that they receive error responses of 429. Too many requests from multiple API methods during peak usage hours. Logs indicate that the Lambda function is never invoked. What could be the cause of the error messages for these customers? A. The Lambda function reached its concurrency limit. B. The Lambda function its region limit for concurrency. C. The company reached its API Gateway account limit for calls per second. D. The company reached its API Gateway default per method limit for calls per second. A company is providing weather data over a REST-based API to several customers. The API is hosted by Amazon API Gateway and is integrated with different AWS Lambda functions for each API operation. The company uses Amazon Route 53 for DNS and has created a resource record of weather.example.com. The company stores data for the API in Amazon DynamoDB tables. The company needs a solution that will give the API the ability to fail over to a different AWS region. Which solution will meet these requirements? A. Deploy a new set of Lambda functions in a new region. Update the API Gateway API to use an edge-optimized API endpoint with Lambda functions from both regions as targets. Convert the DynamoDB tables to global tables. B. Deploy a new API Gateway API and Lambda functions in another region. Change the Route 53 DNS record to a multi-value answer. Add both API Gateway APIs to the answer. Enable target health monitoring. Convert the DynamoDB tables to global tables. C. Deploy a new API Gateway API and Lambda functions in another region. Change the Route 53 DNS record to a failover record. Enable target health monitoring. Convert the DynamoDB tables to global tables. D. Deploy a new API Gateway API in a new region. Change the Lambda functions to global functions. Change the Route 53 DNS record to a multi-value answer. Add both API Gateway APIs to the answer. Enable target health monitoring. Convert the DynamoDB tables to global tables. An enterprise company wants to allow its developers to purchase third-party software through AWS Marketplace. The company uses an AWS organization's account structure with full features enabled and has a shared services account in each organizational unit, OU, that will be used by procurement managers. The procurement team's policy indicates that developers should be able to obtain third-party software from an approved list only and use private marketplace in AWS Marketplace to achieve this requirement. The procurement team wants administration of private marketplace to be restricted to a role named procurement manager role, which could be assumed by procurement managers. Other IAM users, groups, roles, and account administrators in the company should be denied private marketplace administrative access. What is the most efficient way to design an architecture to meet these requirements? A. Create an IAM role named Procurement Manager role in all AWS accounts in the organization. Add the Power User Access Managed policy to the role. Apply an inline policy to all IAM users and roles in every AWS account to deny permissions on the AWS Private Marketplace Admin Full Access Managed policy. B. Create an IAM role named Procurement Manager role in all AWS accounts in the organization. Add the Administrator Access Managed policy to the role. Define a permissions boundary with the AWS Private Marketplace Admin Full Access Managed policy and attach it to all the developer roles. C. Create an IAM role named Procurement Manager role in all the shared services accounts in the organization. Add the AWS Private Marketplace Admin Full Access Managed policy to the role. Create an organization root level SCP to deny permissions to administer private marketplace to everyone except the role named Procurement Manager role. Create another organization root level SCP to deny permissions to create an IAM role named Procurement Manager role to everyone in the organization. B. Create an IAM role named Procurement Manager role in all AWS accounts that will be used by developers. Add the AWS Private Marketplace Admin Full Access Managed policy to the role. Create an SCP in organizations to deny permissions to administer private marketplace to everyone except the role named Procurement Manager role. Apply the SCP to all the shared services accounts in the organization. A company has set up its entire infrastructure on AWS. The company uses Amazon EC2 instances to host its e-commerce website and uses Amazon S3 to store static data. 3 engineers at the company handle the cloud administration and development through one AWS account. Occasionally, An engineer alters an EC2 security group configuration of another engineer and causes non-compliance issues in the environment. A solutions architect must set up a system that tracks changes that the engineers make. The system must send alerts when the engineers make non-compliant changes to the security settings for the EC2 instances. What is the fastest way for the solutions architect to meet these requirements? A. Set up AWS organizations for the company. Apply SCPs to govern and track non-compliant security group changes that are made to the AWS account. B. Enable AWS CloudTrail to capture the changes to EC2 security groups. Enable Amazon CloudWatch rules to provide alerts when non-compliant security settings are detected. C. Enable SCPs on the AWS account to provide alerts when non-compliant security group changes are made to the environment. D. Enable AWS config on the EC2 security groups to track any non-compliant changes. Send the changes as alerts through an Amazon Simple Notification Service, Amazon SNS, topic. A company wants to design a disaster recovery doctor solution for an application that runs in the company's data center. The application writes to an SMB file share and creates a copy on a second file share. Both file shares are in the data center. The application uses two types of files: metadata files and image files. The company wants to store the copy on AWS. The company needs the ability to use SMB to access the data from either the data center or AWS if a disaster occurs. The copy of the data is rarely accessed, but must be available within 5 minutes. A. Deploy AWS outposts with Amazon S3 storage. Configure a Windows Amazon EC2 instance on Outposts as a file server. B. Deploy an Amazon FSx file gateway. Configure an Amazon FSx for Windows File Server multi-AZ file system that uses SSD storage. C. Deploy an Amazon S3 file gateway. Configure the S3 file gateway to use Amazon S3 Standard Infrequent Access, S3 Standard IA, for the metadata files, and to use S3 Glacier Deep Archive for the image files. D. Deploy an Amazon S3 file gateway. Configure the S3 file gateway to use Amazon S3 Standard Infrequent Access, S3 Standard IA, for the metadata files and image files. A company hosts an intranet web application on Amazon EC2 instances behind an application load balancer, ALB. Currently, users authenticate to the application against an internal user database. The company needs to authenticate users to the application by using an existing AWS directory service for Microsoft Active Directory directory. All users with accounts in the directory must have access to the application. Which solution will meet these requirements? A company has used infrastructure as code, IAC, to provision a set of 2 Amazon EC2 instances. The instances have remained the same for several years. The company's business has grown rapidly in the past few months. In response, the company's operations team has implemented an auto-scaling group to manage the sudden increases in traffic. Company policy requires a monthly installation of security updates on all operating systems that are running. The most recent security update required a reboot. As a result, the auto-scaling group terminated the instances and replaced them with new, unpatched instances. Which combination of steps should a solutions architect recommend to avoid a recurrence of this issue? Choose 2. A. Modify the auto-scaling group by setting the update policy to target the oldest launch configuration for replacement. B. Create a new auto-scaling group before the next patch maintenance. During the maintenance window, patch both groups and reboot the instances. C. Create an elastic load balancer in front of the auto-scaling group. Configure monitoring to ensure that target group health checks return healthy after the auto-scaling group replaces the terminated instances. D. Create automation scripts to patch an AMI, update the launch configuration, and invoke an auto-scaling instance refresh. E. Create an elastic load balancer in front of the auto-scaling group. Configure termination protection on the instances. A company operates a fleet of servers on premises and operates a fleet of Amazon EC2 instances in its organization in AWS organizations. The company's AWS accounts contain hundreds of VPCs. The company wants to connect its AWS accounts to its on-premises network. AWS site-to-site VPN connections are already established to a single AWS account. The company wants to control which VPCs can communicate with other VPCs. Which combination of steps will achieve this level of control with the least operational effort? Choose 3. A. Create a transit gateway in an AWS account. Share the transit gateway across accounts by using AWS Resource Access Manager, AWS RAM. B. Configure attachments to all VPCs and VPNs. C. Set up transit gateway route tables. Associate the VPCs and VPNs with the route tables. D. Configure VPC peering between the VPCs. E. Configure attachments between the VPCs and VPNs. F. Set up route tables on the VPCs and VPNs. A company is migrating a legacy application from an on-premises data center to AWS. The application consists of a single application server and a Microsoft SQL Server database server. Each server is deployed on a VMware VM that consumes 500 terabytes of data across multiple attached volumes. The company has established a 10 gigabits per second AWS Direct Connect connection from the closest AWS region to its on-premises data center. The Direct Connect connection is not currently in use by other services. Which combination of steps should a solutions architect take to migrate the application with the least amount of downtime? Choose 2. A. Use an AWS Server Migration Service, AWS SMS replication job, to migrate the database server VM to AWS. B. Use VM import/export to import the application server VM. C. Export the VM images to an AWS Snowball Edge storage optimized device. D. Use an AWS Server Migration Service, AWS SMS replication job to migrate the application server VM to AWS. E. Use an AWS Database Migration Service, AWS DMS replication instance to migrate the database to an Amazon RDS-DB instance. A company runs applications in hundreds of production AWS accounts. The company uses AWS organizations with all features enabled and has a centralized backup operation that uses AWS Backup. The company is concerned about ransomware attacks. To address this concern, the company has created a new policy that all backups must be resilient to breaches of privileged user credentials in any production account. Which combination of steps will meet this new requirement? Choose 3. A. Implement cross-account backup with AWS backup vaults in designated non-production accounts. B. Add an SCP that restricts the modification of AWS backup vaults. C. Implement AWS Backup Vault Lock in compliance mode. C. Implement least privilege access for the IAM service role that is assigned to AWS backup. D. Configure the backup frequency, lifecycle, and retention period to ensure that at least one backup always exists in the cold tier. E. Configure AWS backup to write all backups to an Amazon S3 bucket in a designated non-production account. Ensure that the S3 bucket has S3 object lock enabled. A company implements a containerized application by using Amazon Elastic Container Service, Amazon ECS, and Amazon API Gateway. The application data is stored in Amazon Aurora databases and Amazon DynamoDB databases. The company automates infrastructure provisioning by using AWS CloudFormation. The company automates application deployment by using AWS Code Pipeline. A solutions architect needs to implement a disaster recovery doctor strategy that meets an RPO of 2 hours and an RTO of 4 hours. Which solution will meet these requirements most cost-effectively? A. Set up an Aurora global database and DynamoDB global tables to replicate the databases to a secondary AWS region. In the primary region and in the secondary region, configure an API Gateway API with the regional endpoint. Implement Amazon CloudFront with origin failover to route traffic to the secondary region during a DR scenario. B. Use AWS Database Migration Service, AWS DMS, Amazon Event Bridge, and AWS Lambda to replicate the Aurora databases to a secondary AWS region. Use DynamoDB Streams, Event Bridge, and Lambda to replicate the DynamoDB databases to the secondary region. In the primary region and in the secondary region, configure an API Gateway API with the regional endpoint. Implement Amazon Route 53 failover routing to switch traffic from the primary region to the secondary region. C. Use AWS Backup to create backups of the Aurora databases and the DynamoDB databases in a secondary AWS region. In the primary region and in the secondary region, configure an API Gateway API with the regional endpoint. Implement Amazon Route 53 failover routing to switch traffic from the primary region to the secondary region. D. Set up an Aurora global database and DynamoDB global tables to replicate the databases to a secondary AWS region. In the primary region and in the secondary region, configure an API Gateway API with the regional endpoint. Implement Amazon Route 53 failover routing to switch traffic from the primary region to the secondary region. An application is deployed on Amazon EC2 instances that run in an auto-scaling group. The auto-scaling group configuration uses only one type of instance. CPU and memory utilization metrics show that the instances are underutilized. A solutions architect needs to implement a solution to permanently reduce the EC2 cost and increase the utilization. Which solution will meet these requirements with the least number of configuration changes in the future? A. List instance types that have properties that are similar to the properties that the current instances have. Modify the autoscaling group's launch template configuration to use multiple instance types from the list. B. Use the information about the application's CPU and memory utilization to select an instance type that matches the requirements. Modify the autoscaling group's configuration by adding the new instance type. Remove the current instance type from the configuration. C. Use the information about the application's CPU and memory utilization to specify CPU and memory requirements in a new revision of the autoscaling group's launch template. Remove the current instance type from the configuration. D. Create a script that selects the appropriate instance types from the AWS price list bulk API. Use the selected instance types to create a new revision of the autoscaling group's launch template. A company has deployed its database on an Amazon RDS from MySQL DB instance in the US East 1 region. The company needs to make its data available to customers in Europe. The customers in Europe must have access to the same data as customers in the United States, US, and will not tolerate high application latency or stale data. The customers in Europe and the customers in the US need to write to the database. Both groups of customers need to see updates from the other group in real time. Which solution will meet these requirements? A solutions architect needs to review the design of an Amazon EMR cluster that is using the EMR file system, EMRFS. The cluster performs tasks that are critical to business needs. The cluster is running Amazon EC2 on-demand instances at all times for all task, primary, and core nodes. The EMR tasks run each morning, starting at 1 a.m., and take 6 hours to finish running. The amount of time to complete the processing is not a priority because the data is not referenced until late in the day. The solutions architect must review the architecture and suggest a solution to minimize the compute costs. Which solution should the solutions architect recommend to meet these requirements? A. Launch all task, primary, and core nodes on spot instances in an instance fleet. Terminate the cluster, including all instances, when the processing is completed. B. Launch the primary and core nodes on on-demand instances. Launch the task nodes on spot instances in an instance fleet. Terminate the cluster, including all instances, when the processing is completed. Purchase compute savings plans to cover the on-demand instance usage. C. Continue to launch all nodes on on-demand instances. Terminate the cluster, including all instances, when the processing is completed. Purchase compute savings plans to cover the on-demand instance usage. D. Launch the primary and core nodes on on-demand instances. Launch the task nodes on spot instances in an instance fleet. Terminate only the task node instances when the processing is completed. Purchase compute savings plans to cover the on-demand instance usage. A company's solutions architect is analyzing costs of a multi-application environment. The environment is deployed across multiple availability zones in a single AWS region. After a recent acquisition, the company manages 2 organizations in AWS organizations. The company has created multiple service provider applications as AWS private link-powered VPC endpoint services in one organization. The company has created multiple service consumer applications in the other organization. Data transfer charges are much higher than the company expected, and the solutions architect needs to reduce the costs. The solutions architect must recommend guidelines for developers to follow when they deploy services. These guidelines must minimize data transfer charges for the whole environment. Which guidelines meet these requirements? Choose 2. A. Use AWS Resource Access Manager to share the subnets that host the service provider applications with other accounts in the organization. B. Place the service provider applications and the service consumer applications in AWS accounts in the same organization. C. Turn off cross-zone load balancing for the network load balancer in all service provider application deployments. D. Ensure that service consumer compute resources use the availability zone-specific endpoint service by using the endpoint's local DNS name. E. Create a savings plan that provides adequate coverage for the organization's planned inter-availability zone data transfer usage. An e-commerce company runs an application on AWS. The application has an Amazon API Gateway API that invokes an AWS Lambda function. The data is stored in an Amazon RDS for PostgreSQL DB instance. During the company's most recent flash sale, a sudden increase in API calls negatively affected the application's performance. A solutions architect reviewed the Amazon CloudWatch metrics during that time and noticed a significant increase in Lambda invocations and database connections. The CPU utilization also was high on the DB instance. What should the solutions architect recommend to optimize the application's performance? A. Increase the memory of the Lambda function. Modify the Lambda function to close the database connections when the data is retrieved. B. Add an Amazon Elasticache for Redis cluster to store the frequently accessed data from the RDS database. C. Create an RDS proxy by using the Lambda console. Modify the Lambda function to use the proxy endpoint. D. Modify the Lambda function to connect to the database outside of the function's handler. Check for an existing database connection before creating a new connection. A company wants to migrate its on-premises application to AWS. The database for the application stores structured product data and temporary user session data. The company needs to decouple the product data from the user session data. The company also needs to implement replication in another AWS region for disaster recovery. Which solution will meet these requirements with the highest performance? A. Create an Amazon RDS DB instance with separate schemas to host the product data and the user session data. Configure a read replica for the DB instance in another region. B. Create an Amazon RDS DB instance to host the product data. Configure a read replica for the DB instance in another region. Create a global data store in Amazon Elasticache for Memcached to host the user session data. C. Create 2 Amazon DynamoDB global tables. Use one global table to host the product data. Use the other global table to host the user session data. Use DynamoDB Accelerator (DAX) for caching. D. Create an Amazon RDS DB instance to host the product data. Configure a read replica for the DB instance in another region. Create an Amazon DynamoDB global table to host the user session data. An online retail company is migrating its legacy on-premises .NET application to AWS. The application runs on load-balanced front-end web servers, load-balanced application servers, and a Microsoft SQL Server database. The company wants to use AWS managed services where possible and does not want to rewrite the application. A solutions architect needs to implement a solution to resolve scaling issues and minimize licensing costs as the application scales. Which solution will meet these requirements most cost-effectively? A. Deploy Amazon EC2 instances in an auto-scaling group behind an application load balancer for the web tier and for the application tier. Use Amazon Aurora PostgreSQL with Babelfish turned on to re-platform the SQL Server database. B. Create images of all the servers by using AWS Database Migration Service, AWS DMS. Deploy Amazon EC2 instances that are based on the on-premises imports. Deploy the instances in an auto-scaling group behind a network load balancer for the web tier and for the application tier. Use Amazon DynamoDB as the database tier. C. Containerize the web front-end tier and the application tier. Provision an Amazon Elastic Kubernetes Service, Amazon EKS cluster. Create an auto-scaling group behind a network load balancer for the web tier and for the application tier. Use Amazon RDS for SQL Server to host the database. D. Separate the application functions into AWS Lambda functions. Use Amazon API Gateway for the web front-end tier and the application tier. Migrate the data to Amazon S3. Use Amazon Athena to query the data. A company is storing sensitive data in an Amazon S3 bucket. The company must log all activities for objects in the S3 bucket and must keep the logs for 5 years. The company's security team also must receive an email notification every time there is an attempt to delete data in the S3 bucket. Which combination of steps will meet these requirements most cost-effectively? Choose 3. A. Configure AWS CloudTrail to log S3 data events. B. Configure S3 server access logging for the S3 bucket. C. Configure Amazon S3 to send object deletion events to Amazon Simple Email Service, Amazon SES. D. Configure Amazon S3 to send object deletion events to an Amazon Event Bridge event bus that publishes to an Amazon Simple Notification Service, Amazon SNS topic. E. Configure Amazon S3 to send the logs to Amazon TimeStream with data storage tiering. F. Configure a new S3 bucket to store the logs with an S3 lifecycle policy. A financial company is planning to migrate its web application from on-premises to AWS. The company uses a third-party security tool to monitor the inbound traffic to the application. The company has used the security tool for the last 15 years, and the tool has no cloud solutions available from its vendor. The company's security team is concerned about how to integrate the security tool with AWS technology. The company plans to deploy the application migration to AWS on Amazon EC2 instances. The EC2 instances will run in an auto-scaling group in a dedicated VPC. The company needs to use the security tool to inspect all packets that come in and out of the VPC. This inspection must occur in real time and must not affect the application's performance. A solutions architect must design a target architecture on AWS that is highly available within an AWS region. Which combination of steps should the solutions architect take to meet these requirements? Choose 2. A. Deploy the security tool on EC2 instances M, a new auto-scaling group in the existing VPC. B. Deploy the web application behind a network load balancer. C. Deploy an application load balancer in front of the security tool instances. D. Provision a gateway load balancer for each availability zone to redirect the traffic to the security tool. E. Provision a transit gateway to facilitate communication between VPCs. A health insurance company stores personally identifiable information, PII, in an Amazon S3 bucket. The company uses server-side encryption with S3 Managed Encryption Keys, SSES3, to encrypt the objects. According to a new requirement, all current and future objects in the S3 bucket must be encrypted by keys that the company's security team manages. The S3 bucket does not have versioning enabled. Which solution will meet these requirements? A. In the S3 bucket properties, change the default encryption to SSES3 with a customer-managed key. Use the AWS CLI to re-upload all objects in the S3 bucket. Set an S3 bucket policy to deny unencrypted put object requests. B. In the S3 bucket properties, change the default encryption to server-side encryption with AWS KMS managed encryption keys, SSEKMS. Set an S3 bucket policy to deny unencrypted put object requests. Use the AWS CLI to re-upload all objects in the S3 bucket. C. In the S3 bucket properties, change the default encryption to server-side encryption with AWS KMS managed encryption keys, SSEKMS. Set an S3 bucket policy to automatically encrypt objects on GetObject and PutObject requests. D. In the S3 bucket properties, change the default encryption to AES-256 with a customer-managed key. Attach a policy to deny unencrypted PutObject requests to any entities that access the S3 bucket. Use the AWS CLI to re-upload all objects in the S3 bucket. A company is planning to store a large number of archived documents and make the documents available to employees through the corporate intranet. Employees will access the system by connecting through a client VPN service that is attached to a VPC. The data must not be accessible to the public. The documents that the company is storing are copies of data that is held on physical media elsewhere. The number of requests will be low. Availability and speed of retrieval are not concerns of the company. Which solution will meet these requirements at the lowest cost? A. Create an Amazon S3 bucket. Configure the S3 bucket to use the S31 Zone Infrequent Access S31 Zone IA storage class as default. Configure the S3 bucket for website hosting. Create an S3 interface endpoint. Configure the S3 bucket to allow access only through that endpoint. B. Launch an Amazon EC2 instance that runs a web server. Attach an Amazon Elastic File System, Amazon EFS file system, to store the archived data in the EFS1 Zone Infrequent Access, EFS1 Zone IA storage class. Configure the instance security groups to allow access only from private networks. C. Launch an Amazon EC2 instance that runs a web server. Attach an Amazon Elastic Block Store, Amazon EBS volume to store the archived data. Use the cold HDD SC1 volume type. Configure the instance security groups to allow access only from private networks. D. Create an Amazon S3 bucket. Configure the S3 bucket to use the S3 Glacier Deep Archive Storage class as default. Configure the S3 bucket for website hosting. Create an S3 interface endpoint. Configure the S3 bucket to allow access only through that endpoint. A company has implemented an ordering system using an event-driven architecture. During initial testing, the system stopped processing orders. Further log analysis revealed that one order message in an Amazon Simple Queue service, Amazon SQS, standard queue, was causing an error on the back end and blocking all subsequent order messages. The visibility timeout of the queue is set to 30 seconds, and the back-end processing timeout is set to 10 seconds. A solutions architect needs to analyze faulty order messages and ensure that the system continues to process subsequent messages. Which step should the solutions architect take to meet these requirements? A. Increase the back-end processing timeout to 30 seconds to match the visibility timeout. B. Reduce the visibility timeout of the queue to automatically remove the faulty message. C. Configure a new SQS FIFO queue as a dead letter queue to isolate the faulty messages. D. Configure a new SQS standard queue as a dead letter queue to isolate the faulty messages. A company has created an OU in AWS organizations for each of its engineering teams. Each OU owns multiple AWS accounts. The organization has hundreds of AWS accounts. A solutions architect must design a solution so that each OU can view a breakdown of usage costs across its AWS accounts. Which solution meets these requirements? A. Create an AWS cost and usage report (CUR) for each OU by using AWS Resource Access Manager. Allow each team to visualize the CUR through an Amazon QuickSight dashboard. B. Create an AWS cost and usage report (CUR) from the AWS Organizations Management account. Allow each team to visualize the CUR through an Amazon QuickSight dashboard. C. Create an AWS cost and usage report (CUR) in each AWS Organizations member account. Allow each team to visualize the CUR through an Amazon QuickSight dashboard. B. Create an AWS cost and usage report (CUR) by using AWS Systems Manager. Allow each team to visualize the CUR through Systems Manager Ops Center dashboards. A company provides a centralized Amazon EC2 application hosted in a single shared VPC. The centralized application must be accessible from client applications running in the VPCs of other business units. The centralized application front-end is configured with a network load balancer (NLB) for scalability. Up to 10 business unit VPCs will need to be connected to the shared VPC. Some of the business unit VPC CIDR blocks overlap with the shared VPC, and some overlap with each other. Network connectivity to the centralized application in the shared VPC should be allowed from authorized business unit VPCs only. Which network configuration should a solutions architect use to provide connectivity from the client applications in the business unit VPCs to the centralized application in the shared VPC? A. Create an AWS Transit Gateway. Attach the shared VPC and the authorized business unit VPCs to the Transit Gateway. Create a single Transit Gateway route table and associate it with all of the attached VPCs. Allow automatic propagation of routes from the attachments into the route table. Configure VPC routing tables to send traffic to the Transit Gateway. B. Create a VPC endpoint service using the centralized application NLB and enable the option to require endpoint acceptance. Create a VPC endpoint in each of the business unit VPCs using the service name of the endpoint service. Accept authorized endpoint requests from the Endpoint Service Console. C. Create a VPC peering connection from each business unit VPC to the shared VP. Accept the VPC peering connections from the shared VPC console. Configure VPC routing tables to send traffic to the VPC peering connection. D. Configure a virtual private gateway for the shared VPC and create customer gateways for each of the authorized business unit VPCs. Establish a site-to-site VPN connection from the business unit VPCs to the shared VPC. Configure VPC routing tables to send traffic to the VPN connection. A company has a new application that needs to run on 5 Amazon EC2 instances in a single AWS region. The application requires high-throughput, low-latency network connections between all of the EC2 instances where the application will run. There is no requirement for the application to be fault-tolerant. Which solution will meet these requirements? A. Launch 5 new EC2 instances into a cluster placement group. Ensure that the EC2 instance type supports enhanced networking. B. Launch 5 new EC2 instances into an auto-scaling group in the same availability zone. Attach an extra elastic network interface to each EC2 instance. C. Launch 5 new EC2 instances into a partition placement group. Ensure that the EC2 instance type supports enhanced networking. D. Launch 5 new EC2 instances into a spread placement group. Attach an extra elastic network interface to each EC2 instance. A company is designing an AWS organization structure. The company wants to standardize a process to apply tags across the entire organization. The company will require tags with specific values when a user creates a new resource. Each of the company's OUs will have unique tag values. Which solution will meet these requirements? A. Use an SCP to deny the creation of resources that do not have the required tags. Create a tag policy that includes the tag values that the company has assigned to each OU. Attach the tag policies to the OUs. B. Use an SCP to deny the creation of resources that do not have the required tags. Create a tag policy that includes the tag values that the company has assigned to each OU. Attach the tag policies to the organization's management account. C. Use an SCP to allow the creation of resources only when the resources have the required tags. Create a tag policy that includes the tag values that the company has assigned to each OU. Attach the tag policies to the OUs. D. Use an SCP to deny the creation of resources that do not have the required tags. Define the list of tags. Attach the SCP to the OUs. A company deploys workloads in multiple AWS accounts. Each account has a VPC with VPC flow logs published in text log format to a centralized Amazon S3 bucket. Each log file is compressed with gzip compression. The company must retain the log files indefinitely. A security engineer occasionally analyzes the logs by using Amazon Athena to query the VPC flow logs. The query performance is degrading over time as the number of ingested logs is growing. A solutions architect must improve the performance of the log analysis and reduce the storage space that the VPC flow logs use. Which solution will meet these requirements with the largest performance improvement? A. Create an AWS Lambda function to decompress the gzip files and to compress the files with bzip2 compression. Subscribe the Lambda function to an S3 object created. Put S3 event notification for the S3 bucket. B. Enable S3 transfer acceleration for the S3 bucket. Create an S3 lifecycle configuration to move files to the S3 intelligent tiering storage class as soon as the files are uploaded. C. Update the VPC flowlog configuration to store the files in Apache Parquet format. Specify hourly partitions for the log files. D. Create a new Athena workgroup without data usage control limits. Use Athena Engine version 2. A company wants to containerize a multi-tier web application and move the application from an on-premises data center to AWS. The application includes web, application, and database tiers. The company needs to make the application fault-tolerant and scalable. Some frequently accessed data must always be available across application servers. Front-end web servers need session persistence and must scale to meet increases in traffic. Which solution will meet these requirements with the least ongoing operational overhead? A. Run the application on Amazon Elastic Container Service, Amazon ECS, on AWS Fargate. Use Amazon Elastic File System, Amazon EFS, for data that is frequently accessed between the web and application tiers. Store the front-end web server session data in Amazon Simple Queue Service, Amazon SQS. B. Run the application on Amazon Elastic Container Service, Amazon ECS, on Amazon EC2. Use Amazon ElastiCache for Redis to cache front-end web server session data. Use Amazon Elastic Block Store, Amazon EBS, with multi-attach on EC2 instances that are distributed across multiple availability zones. C. Run the application on Amazon Elastic Kubernetes Service, Amazon EKS. Configure Amazon EKS to use managed node groups. Use replica sets to run the web servers and applications. Create an Amazon Elastic File System, Amazon EFS File System. Mount the EFS file system across all EKS pods to store front-end web server session data. D. Deploy the application on Amazon Elastic Kubernetes Service, Amazon EKS. Configure Amazon EKS to use managed node groups. Run the web servers and application as Kubernetes deployments in the EKS cluster. Store the front-end web server session data in an Amazon DynamoDB table. Create an Amazon Elastic File System, Amazon EFS volume, that all applications will mount at the time of deployment. A company is updating an application that customers use to make online orders. The number of attacks on the application by bad actors has increased recently. The company will host the updated application on an Amazon Elastic Container Service, Amazon ECS cluster. The company will use Amazon DynamoDB to store application data. A public application load balancer, ALB, will provide end users with access to the application. The company must prevent attacks and ensure business continuity with minimal service interruptions during an ongoing attack. Which combination of steps will meet these requirements most cost-effectively? Choose 2. A. Create an Amazon CloudFront distribution with the ALB as the origin. Add a custom header and random value on the CloudFront domain. Configure the ALB to conditionally forward traffic if the header and value match. B. Deploy the application in 2 AWS regions. Configure Amazon Route 53 to route to both regions with equal weight. C. Configure autoscaling for Amazon ECS tasks. Create a DynamoDB accelerator, DAX cluster. D. Configure Amazon ElastiCache to reduce overhead on DynamoDB. E. Deploy an AWS WAF Web ACL that includes an appropriate rule group. Associate the Web ACL with the Amazon CloudFront distribution. A company is designing its network configuration in the AWS cloud. The company uses AWS organizations to manage a multi-account setup. The company has 3 OUs. Each OU contains more than 100 AWS accounts. Each account has a single VPC, and all the VPCs in each OU are in the same AWS region. The CIDR ranges for all the AWS accounts do not overlap. The company needs to implement a solution in which VPCs in the same OU can communicate with each other but cannot communicate with VPCs in other OUs. Which solution will meet these requirements with the least operational overhead? A. Create an AWS CloudFormation stack set that establishes VPC peering between accounts in each OU. Provision the stack set in each OU. B. In each OU, create a dedicated networking account that has a single VPC. Share this VPC with all the other accounts in the OU by using AWS Resource Access Manager, AWS RAM. Create a VPC peering connection between the networking account and each account in the OU. C. Provision a transit gateway in an account in each OU. Share the transit gateway across the organization by using AWS Resource Access Manager, AWS RAM. Create Transit Gateway VPC attachments for each VPC. D. In each OU, create a dedicated networking account that has a single VPC. Establish a VPN connection between the networking account and the other accounts in the OU. Use third-party routing software to route transitive traffic between the VPCs. A company runs an e-commerce application in a single AWS region. The application uses a 5-node Amazon Aurora MySQL DB cluster to store information about customers and their recent orders. The DB cluster experiences a large number of write transactions throughout the day. The company needs to replicate the data in the Aurora database to another region to meet disaster recovery requirements. The company has an RPO of 1 hour. Which solution will meet these requirements with the lowest cost? A. Modify the Aurora database to be an Aurora global database. Create a second Aurora database in another region. B. Enable the backtrack feature for the Aurora database. Create an AWS Lambda function that runs daily to copy the snapshots of the database to a backup region. C. Use AWS Database Migration Service, AWS DMS. Create a DMS change data capture (CDC) task that replicates the ongoing changes from the Aurora database to an Amazon S3 bucket in another region. D. Turn off automated Aurora backups. Configure Aurora backups with a backup frequency of 1 hour. Specify another region as the destination region. Select the Aurora database as the resource assignment. A company has an application that analyzes and stores image data on premises. The application receives millions of new image files every day. Files are an average of 1 megabyte in size. The files are analyzed in batches of 1 gigabyte. When the application analyzes a batch, the application zips the images together. The application then archives the images as a single file in an on-premises NFS server for long-term storage. The company has a Microsoft Hyper-V environment on premises and has compute capacity available. The company does not have storage capacity and wants to archive the images on AWS. The company needs the ability to retrieve archived data within 1 week of a request. The company has a 10 gigabits per second AWS Direct Connect connection between its on-premises data center and AWS. The company needs to set bandwidth limits and schedule archived images to be copied to AWS during non-business hours. Which solution will meet these requirements most cost-effectively? A. Deploy an AWS DataSync agent on a new GPU-based Amazon EC2 instance. Configure the DataSync agent to copy the batch of files from the NFS on-premises server to Amazon S3 Glacier Instant Retrieval. After the successful copy, delete the data from the on-premises storage. B. Deploy an AWS DataSync agent as a Hyper-V VM on-premises. Configure the DataSync agent to copy the batch of files from the NFS on-premises server to Amazon S3 Glacier Deep Archive. After the successful copy, delete the data from the on-premises storage. C. Deploy an AWS DataSync agent on a new general-purpose Amazon EC2 instance. Configure the DataSync agent to copy the batch of files from the NFS on-premises server to Amazon S3 standard. After the successful copy, delete the data from the on-premises storage. Create an S3 lifecycle rule to transition objects from S3 standard to S3 Glacier Deep Archive after 1 day. D. Deploy an AWS Storage Gateway Tape Gateway on premises in the Hyper-V environment. Connect the tape gateway to AWS. Use automatic tape creation. Specify an Amazon S3 Glacier Deep Archive pool. Eject the tape after the batch of images is copied. A company needs to run large batch processing jobs on data that is stored in an Amazon S3 bucket. The jobs perform simulations. The results of the jobs are not time-sensitive, and the process can withstand interruptions. Each job must process 15 to 20 gigabytes of data when the data is stored in the S3 bucket. The company will store the output from the jobs in a different Amazon S3 bucket for further analysis. Which solution will meet these requirements most cost-effectively? A. Create a serverless data pipeline. Use AWS step functions for orchestration. Use AWS Lambda functions with provisioned capacity to process the data. B. Create an AWS batch compute environment that includes Amazon EC2 Spot instances. Specify the spot_capacity optimized allocation strategy. C. Create an AWS batch compute environment that includes Amazon EC2 on-demand instances and Spot instances. Specify the spot_capacity optimized allocation strategy for the Spot instances. D. Use Amazon Elastic Kubernetes Service, Amazon EKS, to run the processing jobs. Use managed node groups that contain a combination of Amazon EC2 on-demand instances and Spot instances. A company runs a microservice as an AWS Lambda function. The microservice writes data to an on-premises SQL database that supports a limited number of concurrent connections. When the number of Lambda function invocations is too high, the database crashes and causes application downtime. The company has an AWS Direct Connect connection between the company's VPC and the on-premises data center. The company wants to protect the database from crashes. Which solution will meet these requirements? A. Write the data to an Amazon Simple Queue service, Amazon SQSQSQ. Configure the Lambda function to read from the queue and write to the existing database. Set a reserved concurrency limit on the Lambda function that is less than the number of connections that the database supports. B. Create a new Amazon Aurora Serverless DB cluster. Use AWS Data Sync to migrate the data from the existing database to Aurora Serverless. Reconfigure the Lambda function to write to Aurora. C. Create an Amazon RDS Proxy DB instance. Attach the RDS Proxy DB instance to the Amazon RDS DB instance. Reconfigure the Lambda function to write to the RDS Proxy DB instance. B. Write the data to an Amazon Simple Notification Service, Amazon SNS topic. Invoke the Lambda function to write to the existing database when the topic receives new messages. Configure provision concurrency for the Lambda function to be equal to the number of connections that the database supports. A company recently deployed an application on AWS. The application uses Amazon DynamoDB. The company measured the application load and configured the RCUs and WCUs on the DynamoDB table to match the expected peak load. The peak load occurs once a week for a 4-hour period and is double the average load. The application load is close to the average load for the rest of the week. The access pattern includes many more writes to the table than reads of the table. A solutions architect needs to implement a solution to minimize the cost of the table. Which solution will meet these requirements? A. Use AWS application autoscaling to increase capacity during the peak period. Purchase reserved RCUs and WCUs to match the average load. B. Configure on-demand capacity mode for the table. C. Configure DynamoDB Accelerator, DAX, in front of the table. Reduce the provisioned read capacity to match the new peak load on the table. D. Configure DynamoDB Accelerator, DAX, in front of the table. Configure on-demand capacity mode for the table. A team of data scientists is using Amazon SageMaker instances and SageMaker APIs to train machine learning (ML) models. The SageMaker instances are deployed in a VPC that does not have access to or from the Internet. Datasets for ML model training are stored in an Amazon S3 bucket. Interface VPC endpoints provide access to Amazon S3 and the SageMaker APIs. Occasionally, the data scientists require access to the Python package index (PyPI) repository to update Python packages that they use as part of their workflow. A solutions architect must provide access to the PyPI repository while ensuring that the SageMaker instances remain isolated from the Internet. Which solution will meet these requirements? A. Create an AWS code commit repository for each package that the data scientists need to access. Configure code synchronization between the PyPI repository and the code commit repository. Create a VPC endpoint for code commit. B. Create a NAT gateway in the VPC. Configure VPC routes to allow access to the Internet with a network ACL that allows access to only the PyPI repository endpoint. C. Create a NAT instance in the configure VPC routes to allow access to the Internet. Configure SageMaker Notebook instance firewall rules that allow access to only the PyPI repository endpoint. D. Create an AWS code artifact domain and repository. Add an external connection for public PyPI to the code artifact repository. Configure the Python client to use the code artifact repository. Create a VPC endpoint for code artifact. A company orchestrates a multi-account structure on AWS by using AWS Control Tower. The company is using AWS Organizations, AWS Config, and AWS Trusted Advisor. The company has a specific OU for development accounts that developers use to experiment on AWS. The company has hundreds of developers, and each developer has an individual development account. The company wants to optimize costs in these development accounts. Amazon EC2 instances and Amazon RDS instances in these accounts must be burstable. The company wants to disallow the use of other services that are not relevant. What should a solutions architect recommend to meet these requirements? A. Create a custom SCP in AWS Organizations to allow the deployment of only burstable instances and to disallow services that are not relevant. Apply the SCP to the development OU. B. Create a custom detective control guardrail in AWS Control Tower. Configure the control guardrail to allow the deployment of only burstable instances and to disallow services that are not relevant. Apply the control guardrail to the development OU. C. Create a custom preventive control guardrail in AWS Control Tower. Configure the control guardrail to allow the deployment of only burstable instances and to disallow services that are not relevant. Apply the control guardrail to the development OU. D. Create an AWS config rule in the AWS Control Tower account. Configure the AWS config rule to allow the deployment of only burstable instances and to disallow services that are not relevant. Deploy the AWS config rule to the development OU by using AWS CloudFormation stack sets. A solutions architect is creating an AWS CloudFormation template from an existing manually created non-production AWS environment. The CloudFormation template can be destroyed and recreated as needed. The environment contains an Amazon EC2 instance. The EC2 instance has an instance profile that the EC2 instance uses to assume a role in a parent account. The solutions architect recreates the role in a CloudFormation template and uses the same role name. When the CloudFormation template is launched in the child account, The EC2 instance can no longer assume the role in the parent account because of insufficient permissions. What should the solutions architect do to resolve this issue? A. In the parent account, edit the trust policy for the role that the EC2 instance needs to assume. Ensure that the target role ARN in the existing statement that allows the STS assume role action is correct. Save the trust policy. B. In the parent account, edit the trust policy for the role that the EC2 instance needs to assume. Add a statement that allows the STS assume role action for the root principal of the child account. Save the trust policy. C. Update the CloudFormation stack again. Specify only the capability _named _IAM capability. D. Update the CloudFormation stack again. Specify the capability _IAM capability and the capability _named _IAM capability. A company's web application has reliability issues. The application serves customers globally. The application runs on a single Amazon EC2 instance and performs read-intensive operations on an Amazon RDS for MySQL database. During high load, the application becomes unresponsive and requires a manual restart of the EC2 instance. A solutions architect must improve the application's reliability. Which solution will meet this requirement with the least development effort? A. Create an Amazon CloudFront distribution. Specify the EC2 instance as the distribution's origin. Configure a multi-AZ deployment for the RDS from MySQL database. Use the standby DB instance for the read-intensive operations. B. Run the application on EC2 instances that are in an auto-scaling group. Place the EC2 instances behind an elastic load balancing (ELB) load balancer. Replace the database service with Amazon Aurora. Use Aurora replicas for the read-intensive operations. C. Deploy AWS Global Accelerator. Configure a multi-AZ deployment for the RDS from MySQL database. Use the standby DB instance for the read-intensive operations. D. Migrate the application to AWS Lambda functions. Create read replicas for the RDS for MySQL database. Use the read replicas for the read-intensive operations. A software development company has multiple engineers who are working remotely. The company is running Active Directory Domain Services (ADDS) on an Amazon EC2 instance. The company's security policy states that all internal, non-public services that are deployed in a VPC must be accessible through a VPN. Multi-factor authentication (MFA) must be used for access to a VPN. What should a solutions architect do to meet these requirements? A. Create an AWS site-to-site VPN connection. Configure integration between a VPN and ADDS. Use an Amazon Workspaces client with MFA support, enabled to establish a VPN connection. B. Create an AWS client VPN endpoint. Create an AD connector directory for integration with ADDS. Enable MFA for AD connector. Use AWS Client VPN to establish a VPN connection. C. Create multiple AWS site-to-site VPN connections by using AWS VPN Cloud Hub. Configure integration between AWS VPN Cloud Hub and ADDS. Use AWS Copilot to establish a VPN connection. D. Create an Amazon WorkLink endpoint. Configure integration between Amazon WorkLink and ADDS. Enable MFA in Amazon WorkLink. Use AWS Client VPN to establish a VPN connection. A company is deploying a new application on AWS. The application consists of an Amazon Elastic Kubernetes service, Amazon EKS, cluster, and an Amazon Elastic Container Registry, Amazon ECR, repository. The EKS cluster has an AWS-managed node group. The company's security guidelines state that all resources on AWS must be continuously scanned for security vulnerabilities. Which solution will meet this requirement with the least operational overhead? A. Activate AWS Security Hub. Configure Security Hub to scan the EKS nodes and the ECR repository. B. Activate Amazon Inspector to scan the EKS nodes and the ECR repository. C. Launch a new Amazon EC2 instance and install a vulnerability scanning tool from AWS Marketplace. Configure the EC2 instance to scan the EKS nodes. Configure Amazon ECR to perform a basic scan on push. D. Install the Amazon CloudWatch agent on the EKS nodes. Configure the CloudWatch agent to scan continuously. Configure Amazon ECR to perform a basic scan on push. A team collects and routes behavioral data for an entire company. The company runs a multi-AZ VPC environment with public subnets, private subnets, and an internet gateway. Each public subnet also contains a NAT gateway. Most of the company's applications read from and write to Amazon Kinesis data streams. Most of the workloads run in private subnets. A solutions architect must review the infrastructure. The solution architect needs to reduce costs and maintain the function of the applications. The solutions architect uses Cost Explorer and notices that the cost in the EC2 other category is consistently high. A further review shows that NAT gateway bytes charges are increasing the cost in the EC2 other category. What should the solutions architect do to meet these requirements? A. Enable VPC flow logs. Use Amazon Athena to analyze the logs for traffic that can be removed. Ensure that security groups are blocking traffic that is responsible for high costs. B. Add an interface VPC endpoint for Kinesis data streams to the VPC. Ensure that applications have the correct IAM permissions to use the interface VPC endpoint. C. Enable VPC flow logs and Amazon Detective. Review detective findings for traffic that is not related to Kinesis data streams. Configure security groups to block that traffic. D. Add an interface VPC endpoint for Kinesis data streams to the VPC. Ensure that the VPC endpoint policy allows traffic from the applications. A company is planning to migrate an on-premises data center to AWS. The company currently hosts the data center on Linux-based VMware VMs. A solutions architect must collect information about network dependencies between the VMs. The information must be in the form of a diagram that details host IP addresses, host names, and network connection information. Which solution will meet these requirements? A. Use AWS Application Discovery Service. Select an AWS Migration Hub Home AWS region. Install the AWS Application Discovery Agent on the on-premises servers for data collection. Grant permissions to Application Discovery Service to use the Migration Hub network diagrams. B. Use the AWS Application Discovery Service Agentless Collector for server data collection. Export the network diagrams from the AWS Migration Hub in .png format. C. Install the AWS Application Migration Service Agent on the on-premises servers for data collection. Use AWS Migration Hub data in Workload Discovery on AWS to generate network diagrams. D. Install the AWS Application Migration Service Agent on the on-premises servers for data collection. Export data from AWS Migration Hub in .csv format into an Amazon CloudWatch dashboard to generate network diagrams. A company wants to use Amazon workspaces in combination with thin client devices to replace aging desktops. Employees use the desktops to access applications that work with clinical trial data. Corporate security policy states that access to the applications must be restricted to only company branch office locations. The company is considering adding an additional branch office in the next 6 months. Which solution meets these requirements with the most operational efficiency? A. Create an IP access control group rule with the list of public addresses from the branch offices. Associate the IP access control group with the workspaces directory. B. Use AWS Firewall Manager to create a web ACL rule with an IP set with the list of public addresses from the branch office locations. Associate the web ACL with the workspaces directory. C. Use AWS Certificate Manager (ACM) to issue trusted device certificates to the machines deployed in the branch office locations. Enable restricted access on the workspaces directory. D. Create a custom workspace image with Windows Firewall configured to restrict access to the public addresses of the branch offices. Use the image to deploy the workspaces. A large company is migrating its entire IT portfolio to AWS. Each business unit in the company has a standalone AWS account that supports both development and test environments. New accounts to support production workloads will be needed soon. The finance department requires a centralized method for payment, but must maintain visibility into each group's spending to allocate costs. The security team requires a centralized mechanism to control IAM usage in all the company's accounts. What combination of the following options meets the company's needs with the least effort? Choose 2. A. Use a collection of parameterized AWS CloudFormation templates defining common IAM permissions that are launched into each account. Require all new and existing accounts to launch the appropriate stacks to enforce the least privilege model. B. Use AWS organizations to create a new organization from a chosen payer account and define an organizational unit hierarchy. Invite the existing accounts to join the organization and create new accounts using organizations. C. Require each business unit to use its own AWS accounts. Tag each AWS account appropriately and enable Cost Explorer to administer chargebacks. D. Enable all features of AWS organizations and establish appropriate service control policies that filter IAM permissions for subaccounts. E. Consolidate all of the company's AWS accounts into a single AWS account. Use tags for billing purposes and the IAM's Access Advisor feature to enforce the least privilege model. A company wants to migrate its on-premises data center to the AWS cloud. This includes thousands of virtualized Linux and Microsoft Windows servers, SAN storage, Java and PHP applications with MySQL and Oracle databases. There are many dependent services hosted either in the same data center or externally. The technical documentation is incomplete and outdated. A solutions architect needs to understand the current environment and estimate the cloud resource costs after the migration. Which tools or services should the solutions architect use to plan the cloud migration? Choose 3. A. AWS Application Discovery Service. B. AWS SMS. C. AWS X-Ray D. AWS Cloud Adoption Readiness Tool, CART E. Amazon Inspector. F. AWS Migration Hub. A company that is developing a mobile game is making game assets available in 2 AWS regions. Game assets are served from a set of Amazon EC2 instances behind an application load balancer, ALB, in each region. The company requires game assets to be fetched from the closest region. If game assets become unavailable in the closest region, they should be fetched from the other region. What should a solutions architect do to meet these requirements? A. Create an Amazon CloudFront distribution. Create an origin group with one origin for each ALB. Set one of the origins as primary. B. Create an Amazon Route 53 health check for each AL. Create a Route 53 failover routing record pointing to the two ALBs. Set the evaluate target health value to yes. C. Create two Amazon CloudFront distributions, each with one ALB as the origin. Create an Amazon Route 53 failover routing record pointing to the two CloudFront distributions. Set the evaluate target health value to yes. D. Create an Amazon Route 53 health check for each ALB. Create a Route 53 latency alias record pointing to the two ALBs. Set the evaluate target health value to yes. A retail company has an on-premises data center in Europe. The company also has a multi-region AWS presence that includes the EU West 1 and US East 1 regions. The company wants to be able to route network traffic from its on-premises infrastructure into VPCs in either of those regions. The company also needs to support traffic that is routed directly between VPCs in those regions. No single points of failure can exist on the network. The company already has created two 1 gigabit per second AWS Direct Connect connections from its on-premises data center. Each connection goes into a separate Direct Connect location in Europe for high availability. These two locations are named DXA and DXB, respectively. Each region has a single AWS transit gateway that is configured to route all inter-VPC traffic within that region. Which solution will meet these requirements? A company stores and manages documents in an Amazon Elastic File System, Amazon EFS file system. The file system is encrypted with an AWS Key Management Service, AWS KMS key. The file system is mounted to an Amazon EC2 instance that runs proprietary software. The company has enabled automatic backups for the file system. The automatic backups use the AWS Backup Default Backup Plan. A solutions architect must ensure that deleted documents can be recovered within an RPO of 100 minutes. Which solution will meet these requirements? A. Create a new IAM role. Create a new backup plan. Use the new IAM role to create backups. Update the KMS key policy to allow the new IAM role to use the key. Implement an hourly backup schedule for the file system. B. Create a new backup plan. Update the KMS key policy to allow the AWS service role for backup IAM role to use the key. Implement a custom cron expression to run a backup of the file system every 30 minutes. C. Create a new IAM role. Use the existing backup plan. Update the KMS key policy to allow the new IAM role to use the key. Enable continuous backups for point-in-time recovery. D. Use the existing backup plan. Update the KMS key policy to allow the AWS service role for backup IAM role to use the key. Enable cross-region replication for the file system. A company is designing an AWS environment for a manufacturing application. The application has been successful with customers, and the application's user base has increased. The company has connected the AWS environment to the company's on-premises data center through a 1 gigabit per second AWS Direct Connect connection. The company has configured BGP for the connection. the company must update the existing network connectivity solution to ensure that the solution is highly available, fault-tolerant, and secure. Which solution will meet these requirements most cost-effectively? A. Add a dynamic private IP AWS site-to-site VPN as a secondary path to secure data in transit and provide resilience for the direct connect connection. Configure MACsec to encrypt traffic inside the direct connect connection. B. Provision another direct connect connection between the company's on-premises data center and AWS to increase the transfer speed and provide resilience. Configure MACsec to encrypt traffic inside the direct connect connection. C. Configure multiple private VIFs. Load balance data across the VIFs between the on-premises data center and AWS to provide resilience. D. Add a static AWS site-to-site VPN as a secondary path to secure data in transit and to provide resilience for the direct connect connection. A company has an on-premises data center and is using Kubernetes to develop a new solution on AWS. The company uses Amazon Elastic Kubernetes Service, Amazon EKS, clusters for its development and test environments. The EKS control plane and data plane for production workloads must reside on premises. The company needs an AWS-managed solution for Kubernetes management. Which solution will meet these requirements with the least operational overhead? A. Install an AWS Outpost server in the on-premises data center. Deploy Amazon EKS by using a local cluster configuration on the Outpost server for the production workloads. B. Install Amazon EKS anywhere on the company's hardware in the on-premises data center. Deploy the production workloads on an EKS Anywhere cluster. C. Install an AWS Outpost server in the on-premises data center. Deploy Amazon EKS by using an extended cluster configuration on the Outpost server for the production workloads. D. Install an AWS Outpost server in the on-premises data center. Install Amazon EKS Anywhere on the Outpost server. Deploy the production workloads on an EKS Anywhere cluster. A company is running applications on AWS in a multi-account environment. The company's sales team and marketing team use separate AWS accounts in AWS organizations. The sales team stores petabytes of data in an Amazon S3 bucket. The marketing team uses Amazon QuickSight for data visualizations. The marketing team needs access to data that the sales team stores in the S3 bucket. The company has encrypted the S3 bucket with an AWS Key Management Service, AWS KMS Key. The marketing team has already created the IAM service role for QuickSight to provide QuickSight access in the marketing AWS account. The company needs a solution that will provide secure access to the data in the S3 bucket across AWS accounts. Which solution will meet these requirements with the least operational overhead? A. Create a new S3 bucket in the marketing account. Create an S3 replication rule in the sales account to copy the objects to the new S3 bucket in the marketing account. Update the QuickSight permissions in the marketing account to grant access to the new S3 bucket. B. Create an SCP to grant access to the S3 bucket to the marketing account. Use AWS Resource Access Manager, AWS RAM, to share the KMS key from the sales account with the marketing account. Update the QuickSight permissions in the marketing account to grant access to the S3 bucket. C. Update the S3 bucket policy in the marketing account to grant access to the QuickSight role. Create a KMS grant for the encryption key that is used in the S3 bucket. Grant decrypt access to the QuickSight role. Update the QuickSight permissions in the marketing account to grant access to the S3 bucket. D. Create an IAM role in the sales account and grant access to the S3 bucket. From the marketing account, assume the IAM role in the sales account to access the S3 bucket. Update the QuickSight route to create a trust relationship with the new IAM role in the sales account. A company runs a content management application on a single Windows Amazon EC2 instance in a development environment. The application reads and writes static content to a 2 TB Amazon Elastic Block Store, Amazon EBS volume, that is attached to the instance as the root device. The company plans to deploy this application in production as a highly available and fault-tolerant solution that runs on at least 3 EC2 instances across multiple availability zones. A solutions architect must design a solution that joins all the instances that run the application to an Active Directory domain. The solution also must implement Windows ACLs to control access to file contents. The application always must maintain exactly the same content on all running instances at any given point in time. Which solution will meet these requirements with the least management overhead? A. Create an Amazon Elastic File System, Amazon EFS file share. Create an auto-scaling group that extends across 3 availability zones and maintains a minimum size of 3 instances. Implement a user data script to install the application, join the instance to the AD domain, and mount the EFS file share. B. Create a new AMI from the current EC2 instance that is running. Create an Amazon FSx for Lustre file system. Create an auto-scaling group that extends across 3 availability zones and maintains a minimum size of 3 instances. Implement a user data script to join the instance to the AD domain and mount the FSx for Lustre file system. C. Create an Amazon FSx for Windows File Server file system. Create an auto-scaling group that extends across 3 availability zones and maintains a minimum size of 3 instances. Implement a user data script to install the application and mount the FSx for Windows File Server file system. Perform a seamless domain join to join the instance to the AD domain. D. Create a new AMI from the current EC2 instance that is running. Create an Amazon Elastic File System, Amazon EFS file system. Create an auto-scaling group that extends across 3 availability zones and maintains a minimum size of 3 instances. Perform a seamless domain join to join the instance to the AD domain. A software-as-a-service (SaaS) company provides a media software solution to customers. The solution is hosted on 50 VPCs across various AWS regions and AWS accounts. One of the VPCs is designated as a management VPC. The compute resources in the VPCs work independently. The company has developed a new feature that requires all 50 VPCs to be able to communicate with each other. The new feature also requires one-way access from each customer's VPC to the company's management VPC. The management VPC hosts a compute resource that validates licenses for the media software solution. The number of VPCs that the company will use to host the solution will continue to increase as the solution grows. Which combination of steps will provide the required VPC connectivity with the least operational overhead? Choose 2. A. Create a transit gateway. Attach all the company's VPCs and relevant subnets to the transit gateway. B. Create VPC peering connections between all the company's VPCs. C. Create a network load balancer, NLB, that points to the compute resource for license validation. Create an AWS private link endpoint service that is available to each customer's VP. Associate the endpoint service with the NLB. D. Create a VPN appliance in each customer's VPC. Connect the company's management VPC to each customer's VPC by using AWS Site-to-Site VPN. E. Create a VPC peering connection between the company's management VPC and each customer's VPC. A company is developing a new service that will be accessed using TCP on a static port. A solutions architect must ensure that the service is highly available, has redundancy across availability zones, and is accessible using the DNS name my.service.com, which is publicly accessible. The service must use fixed address assignments, so other companies can add the addresses to their allow lists. Assuming that resources are deployed in multiple availability zones in a single region, which solution will meet these requirements? A company is using Amazon Open Search Service to analyze data. The company loads data into an Open Search Service cluster with 10 data nodes from an Amazon S3 bucket that uses S3 standard storage. The data resides in the cluster for 1 month for read-only analysis. After 1 month, the company deletes the index that contains the data from the cluster. For compliance purposes, the company must retain a copy of all input data. The company is concerned about ongoing costs and asks a solutions architect to recommend a new solution. Which solution will meet these requirements most cost-effectively? A. Replace all the data nodes with ultra-warm nodes to handle the expected capacity. Transition the input data from S3 Standard to S3 Glacier Deep Archive when the company loads the data into the cluster. B. Reduce the number of data nodes in the cluster to 2. Add ultra-warm nodes to handle the expected capacity. Configure the indexes to transition to ultra-warm when Open Search Service ingests the data. Transition the input data to S3 Glacier Deep Archive after 1 month by using an S3 lifecycle policy. C. Reduce the number of data nodes in the cluster to 2. Add ultra-warm nodes to handle the expected capacity. Configure the indexes to transition to ultra-warm when Open Search Service ingests the data. Add cold storage nodes to the cluster. Transition the indexes from ultra-warm to cold storage. Delete the input data from the S3 bucket after 1 month by using an S3 lifecycle policy. D. Reduce the number of data nodes in the cluster to 2. Add instance-backed data nodes to handle the expected capacity. Transition the input data from S3 Standard to S3 Glacier Deep Archive when the company loads the data into the cluster. A company that has multiple business units is using AWS organizations with all features enabled. The company has implemented an account structure in which each business unit has its own AWS account. Administrators in each AWS account need to view detailed cost and utilization data for their account by using Amazon Athena. Each business unit can have access to only its own cost and utilization data. The IAM policies that govern the ability to set up AWS cost and usage reports are in place. A central cost and usage report that contains all data for the organization is already available in an Amazon S3 bucket. Which solution will meet these requirements with the least operational complexity? A. In the organization's management account, use AWS Resource Access Manager, AWS RAM, to share the cost and usage report data with each member account. B. In the organization's management account, configure an S3 event to invoke an AWS Lambda function each time a new file arrives in the S3 bucket that contains the central cost and usage report. Configure the Lambda function to extract each member account's data and to place the data in Amazon S3 under a separate prefix. Modify the S3 bucket policy to allow each member account to access its own prefix. C. In each member account, access AWS Cost Explorer. Create a new report that contains relevant cost information for the account. Save the report in Cost Explorer. Provide instructions that the account administrators can use to access the saved report. D. In each member account, create a new S3 bucket to store cost and usage report data. Set up a cost and usage report to deliver the data to the new S3 bucket. A company has registered 10 new domain names. The company uses the domains for online marketing. The company needs a solution that will redirect online visitors to a specific URL for each domain. All domains and target URLs are defined in a JSON document. All DNS records are managed by Amazon Route 53. A solutions architect must implement a redirect service that accepts HTTP and HTTPS requests. Which combination of steps should the solutions architect take to meet these requirements with the least amount of operational effort? Choose 3. A. Create a dynamic web page that runs on an Amazon EC2 instance. Configure the web page to use the JSON document in combination with the event message to look up and respond with a redirect URL. B. Create an application load balancer that includes HTTP and HTTPS listeners. C. Create an AWS Lambda function that uses the JSON document in combination with the event message to look up and respond with a redirect URL. D. Use an Amazon API Gateway API with a custom domain to publish an AWS Lambda function. E. Create an Amazon CloudFront distribution. Deploy a Lambda at Edge function. F. Create an SSL certificate by using AWS Certificate Manager, ACM. Include the domains as subject alternative names. A company is running its solution on AWS in a manually created VPC. The company is using AWS CloudFormation to provision other parts of the infrastructure. According to a new requirement, the company must manage all infrastructure in an automatic way. What should the company do to meet this new requirement with the least effort? A. Create a new AWS Cloud Development Kit, AWS CDK, stack, that strictly provisions the existing VPC resources and configuration. Use AWS CDK to import the VPC into the stack and to manage the VPC. B. Create a CloudFormation stack set that creates the VPC. Use the stack set to import the VPC into the stack. C. Create a new CloudFormation template that strictly provisions the existing VPC resources and configuration. From the CloudFormation console, create a new stack by importing the existing resources. D. Create a new CloudFormation template that creates the VPC. Use the AWS Serverless Application Model, AWS SAM CLI, to import the VPC. A company is storing data on premises on a Windows file server. The company produces 5 and NBSP GB of new data daily. The company migrated part of its Windows-based workload to AWS and needs the data to be available on a file system in the cloud. The company already has established an AWS Direct Connect connection between the on-premises network and AWS. Which data migration strategy should the company use? A. Use the File Gateway option in AWS Storage Gateway to replace the existing Windows file server and point the existing file share to the new File Gateway. B. Use AWS DataSync to schedule a daily task to replicate data between the on-premises Windows file server and Amazon FSx. C. Use AWS data pipeline to schedule a daily task to replicate data between the on-premises Windows file server and Amazon Elastic File System, Amazon EFS. A. Use AWS Data Sync to schedule a daily task to replicate data between the on-premises Windows file server and Amazon Elastic File System, Amazon EFS. A company is hosting a monolithic REST-based API for a mobile app on 5 Amazon EC2 instances in public subnets of a VPC. Mobile clients connect to the API by using a domain name that is hosted on Amazon Route 53. The company has created a Route 53 multi-value answer routing policy with the IP addresses of all the EC2 instances. Recently, the app has been overwhelmed by large and sudden increases to traffic. The app has not been able to keep up with the traffic. A solutions architect needs to implement a solution so that the app can handle the new and varying load. Which solution will meet these requirements with the least operational overhead? A. Separate the API into individual AWS Lambda functions. Configure an Amazon API Gateway REST API with Lambda integration for the backend. Update the Route 53 record to point to the API Gateway API. B. Containerize the API logic. Create an Amazon Elastic Kubernetes service, Amazon EKS cluster. Run the containers in the cluster by using Amazon EC2. Create a Kubernetes ingress. Update the Route 53 record to point to the Kubernetes ingress. C. Create an autoscaling group. Place all the EC2 instances in the autoscaling group. Configure the autoscaling group to perform scaling actions that are based on CPU utilization. Create an AWS Lambda function that reacts to autoscaling group changes and updates the Route 53 record. D. Create an application load balancer, ALB, in front of the API. Move the EC2 instances to private subnets in the VPC. Add the EC2 instances as targets for the ALB. Update the Route 53 record to point to the ALB. A company solutions architect is reviewing a web application that runs on AWS. The application references static assets in an Amazon S3 bucket in the US East 1 region. The company needs resiliency across multiple AWS regions. The company already has created an S3 bucket in a second region. Which solution will meet these requirements with the least operational overhead? A. Configure the application to write each object to both S3 buckets. Set up an Amazon Route 53 public hosted zone with a record set by using a weighted routing policy for each S3 bucket. Configure the application to reference the objects by using the Route 53 DNS name. B. Create an AWS Lambda function to copy objects from the S3 bucket in US East 1 to the S3 bucket in the second region. Invoke the Lambda function each time an object is written to the S3 bucket in US East 1. Set up an Amazon CloudFront distribution with an origin group that contains the two S3 buckets as origins. C. Configure replication on the S3 bucket in US East 1 to replicate objects to the S3 bucket in the second region. Set up an Amazon CloudFront distribution with an origin group that contains the two S3 buckets as origins. D. Configure replication on the S3 bucket in US East 1 to replicate objects to the S3 bucket in the second region. If failover is required, update the application code to load S3 objects from the S3 bucket in the second region. A retail company is mounting IoT sensors in all of its stores worldwide. During the manufacturing of each sensor, the company's private certificate authority, CA, issues an X509 certificate that contains a unique serial number. The company then deploys each certificate to its respective sensor. A solutions architect needs to give the sensors the ability to send data to AWS after they are installed. Sensors must not be able to send data to AWS until they are installed. Which solution will meet these requirements? A. Create an AWS Lambda function that can validate the serial number. Create an AWS IoT Core provisioning template. Include the serial number parameter in the parameters section. Add the Lambda function as a pre-provisioning hook. During manufacturing, call the register thing API operation and specify the template and parameters. B. Create an AWS step function state machine that can validate the serial number. Create an AWS IoT Core provisioning template. Include the serial number parameter in the parameters section. Specify the step function state machine to validate parameters. Call the start thing registration task API operation during installation. C. Create an AWS Lambda function that can validate the serial number. Create an AWS IoT Core provisioning template. Include the serial number parameter in the parameters section. Add the Lambda function as a pre-provisioning hook. Register the CA with AWS IoT Core. Specify the provisioning template and set the Allow Auto Registration parameter. D. Create an AWS IoT Core provisioning template. Include the serial number parameter in the parameters section. Include parameter validation in the template. Provision a claim certificate and a private key for each device that uses the CA. Grant AWS IoT Core service permissions to update AWS IoT things during provisioning. A company is developing a gene reporting device that will collect genomic information to assist researchers with collecting large samples of data from a diverse population. The device will push 8 kilobytes of genomic data every second to a data platform that will need to process and analyze the data and provide information back to researchers. The data platform must meet the following requirements. Provide near real-time analytics of the inbound genomic data. Ensure the data is flexible, parallel, and durable. Deliver results of processing to a data warehouse. Which strategy should a solutions architect use to meet these requirements? A. Use Amazon Kinesis Data Firehose to collect the inbound sensor data, analyze the data with Kinesis clients, and save the results to an Amazon RDS instance. B. Use Amazon Kinesis data streams to collect the inbound sensor data, analyze the data with Kinesis clients, and save the results to an Amazon Redshift cluster using Amazon EMR. C. Use Amazon S3 to collect the inbound device data, analyze the data from Amazon SQS with Kinesis, and save the results to an Amazon Redshift cluster. D. Use an Amazon API gateway to put requests into an Amazon SQS queue, analyze the data with an AWS Lambda function, and save the results to an Amazon Redshift cluster using Amazon EMR. A company is using multiple AWS accounts and has multiple DevOps teams running production and non-production workloads in these accounts. The company would like to centrally restrict access to some of the AWS services that the DevOps teams do not use. The company decided to use AWS organizations and successfully invited all AWS accounts into the organization. They would like to allow access to services that are currently in use and deny a few specific services. Also, they would like to administer multiple accounts together as a single unit. What combination of steps should the solutions architect take to satisfy these requirements? Choose 3. A. Use a denialist strategy. B. Review the Access Advisor in AWS IAM to determine services recently used. C. Review the AWS Trusted Advisor Report to determine services recently used. D. Remove the default Full AWS Access (SCP). E. Define organizational units (OUs) and place the member accounts in the OUs. F. Remove the default Deny AWS Access (SCP). A company wants to establish a dedicated connection between its on-premises infrastructure and AWS. The company is setting up a 1 gigabit per second AWS Direct Connect connection to its account VPC. The architecture includes a transit gateway and a direct connect gateway to connect multiple VPCs and the on-premises infrastructure. The company must connect to VPC resources over a transit VIF by using the Direct Connect connection. Which combination of steps will meet these requirements? Choose 2. A. Update the 1 gigabit per second Direct Connect connection to 10 gigabits per second. B. Advertise the on-premises network prefixes over the transit VIF. C. Advertise the VPC prefixes from the Direct Connect gateway to the on-premises network over the transit VIF. D. Update the Direct Connect connection's MACsec encryption mode attribute to must_encrypt. E. Associate a MACsec connection key name, Connectivity Association Key, CKN/CAK, pair with the Direct Connect connection. A solutions architect works for a government agency that has strict disaster recovery requirements. All Amazon Elastic Block Store (Amazon EBS) snapshots are required to be saved in at least 2 additional AWS regions. The agency also is required to maintain the lowest possible operational overhead. Which solution meets these requirements? A. Configure a policy in Amazon Data Lifecycle Manager (Amazon DLM) to run once daily to copy the EBS snapshots to the additional regions. B. Use Amazon Event Bridge to schedule an AWS Lambda function to copy the EBS snapshots to the additional regions. C. Set up AWS Backup to create the EBS snapshots. Configure Amazon S3 cross-region replication to copy the EBS snapshots to the additional regions. D. Schedule Amazon EC2 Image Builder to run once daily to create an AMI and copy the AMI to the additional regions. A company is in the process of implementing AWS organizations to constrain its developers to use only Amazon EC2, Amazon S3, and Amazon DynamoDB. The developer's account resides in a dedicated organizational unit, OU. The solutions architect has implemented the following SCP on the developer's account. When this policy is deployed, IAM users in the developer's account are still able to use AWS services that are not listed in the policy. What should the solutions architect do to eliminate the developer's ability to use services outside the scope of this policy? A. Create an explicit deny statement for each AWS service that should be constrained. B. Remove the full AWS Access SCP from the developer's account's OU. C. Modify the full AWS Access SCP to explicitly deny all services. D. Add an explicit deny statement using a wildcard to the end of the SCP. A company is using Amazon API Gateway to deploy a private REST API that will provide access to sensitive data. The API must be accessible only from an application that is deployed in a VPC. The company deploys the API successfully. However, the API is not accessible from an Amazon EC2 instance that is deployed in the VPC. Which solution will provide connectivity between the EC2 instance and the API? A. Create an interface VPC endpoint for API gateway. Attach an endpoint policy that allows API gateway actions. Disable private DNS naming for the VPC endpoint. Configure an API resource policy that allows access from the VPC. Use the VPC endpoint SDNS name to access the API. B. Create an interface VPC endpoint for API gateway. Attach an endpoint policy that allows the execute API invoke action. Enable private DNS naming for the VPC endpoint. Configure an API resource policy that allows access from the VPC endpoint. Use the API endpoint SDNS names to access the API. C. Create a network load balancer (NLB) and a VPC link. Configure private integration between API gateway and the NLB. Use the API endpoint SDNS names to access the API. D. Create an application load balancer (ALB) and a VPC link. Configure private integration between API gateway and the ALB. Use the ALB endpoint SDNS name to access the API. A company wants to manage the costs associated with a group of 20 applications that are infrequently used, but are still business critical, by migrating to AWS. The applications are a mix of Java and Node.js spread across different instance clusters. The company wants to minimize costs while standardizing by using a single deployment methodology. Most of the applications are part of month-end processing routines with a small number of concurrent users, but they are occasionally run at other times. Average application memory consumption is less than 1 gigabyte, though some applications use as much as 2.5 gigabytes of memory during peak processing. The most important application in the group is a billing report written in Java that accesses multiple data sources and often runs for several hours. Which is the most cost-effective solution? A. Deploy a separate AWS Lambda function for each application. Use AWS CloudTrail logs and Amazon CloudWatch alarms to verify completion of critical jobs. B. Deploy Amazon ECS containers on Amazon EC2 with autoscaling configured for memory utilization of 75%. Deploy an ECS task for each application being migrated with ECS task scaling. Monitor services and hosts by using Amazon CloudWatch. C. Deploy AWS Elastic Beanstalk for each application with autoscaling to ensure that all requests have sufficient resources. Monitor each AWS Elastic Beanstalk deployment by using CloudWatch alarms. D. Deploy a new Amazon EC2 instance cluster that co-hosts all applications by using EC2 autoscaling and application load balancers. Scale cluster size based on a custom metric set on instance memory utilization. Purchase 3-year reserved instance reservations equal to the group max size parameter of the autoscaling group. A company has deployed an Amazon Connect contact center. Contact center agents are reporting large numbers of computer-generated calls. The company is concerned about the cost and productivity effects of these calls. The company wants a solution that will allow agents to flag the call as spam and automatically block the numbers from going to an agent in the future. What is the most operationally efficient solution to meet these requirements? A. Customize the Contact Control Panel (CCP) by adding a flag call button that will invoke an AWS Lambda function that calls the update contact attributes API. Use an Amazon DynamoDB table to store the spam numbers. Modify the contact flows to look for the updated attribute, and to use a Lambda function to read and write to the DynamoDB table. B. Use a contact lens for Amazon Connect rule that will look for spam calls. Use an Amazon DynamoDB table to store the spam numbers. Modify the contact flows to look for the rule and to invoke an AWS Lambda function to read and write to the DynamoDB table. C. Use an Amazon DynamoDB table to store the spam numbers. Create a quick connect that the agents can transfer the spam call to from the Contact Control Panel, CCP. Modify the quick connect contact flow to invoke an AWS Lambda function to write to the DynamoDB table. D. Modify the initial contact flow to ask for caller input. If the agent does not receive input, the agent should mark the caller as spam. Use an Amazon DynamoDB table to store the spam numbers. Use an AWS Lambda function to read and write to the DynamoDB table. A company runs an intranet application on premises. The company wants to configure a cloud backup of the application. The company has selected AWS Elastic Disaster Recovery for this solution. The company requires that replication traffic does not travel through the public internet. The application also must not be accessible from the internet. The company does not want this solution to consume all available network bandwidth because other applications require bandwidth. Which combination of steps will meet these requirements? Choose 3. A. Create a VPC that has at least 2 private subnets, 2 NAT gateways, and a virtual private gateway. B. Create a VPC that has at least 2 public subnets, a virtual private gateway, and an internet gateway. C. Create an AWS site-to-site VPN connection between the on-premises network and the target AWS network. D. Create an AWS Direct Connect connection and a Direct Connect gateway between the on-premises network and the target AWS network. E. During configuration of the replication servers, select the option to use private IP addresses for data replication. F. During configuration of the launch settings for the target servers, select the option to ensure that the recovery instance's private IP address matches the source server's private IP address. A company is planning to migrate its on-premises VMware cluster of 120 VMs to AWS. The VMs have many different operating systems and many custom software packages installed. The company also has an on-premises NFS server that is 10 terabytes in size. The company has set up a 10 gigabits per second AWS Direct Connect connection to AWS for the migration. Which solution will complete the migration to AWS in the least amount of time? A. Export the on-premises VMs and copy them to an Amazon S3 bucket. Use VM imports/export to create AMIs from the VM images that are stored in Amazon S3. Order an AWS Snowball Edge device. Copy the NFS server data to the device. Restore the NFS server data to an Amazon EC2 instance that has NFS configured. B. Configure AWS Application Migration Service with a connection to the VMware cluster. Create a replication job for the VMS. Create an Amazon Elastic File System, Amazon EFS file system. Configure AWS DataSync to copy the NFS server data to the EFS file system over the Direct Connect connection. C. Recreate the VMs on AWS as Amazon EC2 instances. Install all the required software packages. Create an Amazon FSx for Lustre file system. Configure AWS DataSync to copy the NFS server data to the FSx for Lustre file system over the Direct Connect connection. D. Order 2 AWS Snowball Edge devices. Copy the VMs and the NFS server data to the devices. Run VM import, export after the data from the devices is loaded to an Amazon S3 bucket. Create an Amazon Elastic File System, Amazon EFS file system. Copy the NFS server data from Amazon S3 to the EFS file system. A company is building an electronic document management system in which users upload their documents. The application stack is entirely serverless and runs on AWS in the EU Central 1 region. The system includes a web application that uses an Amazon CloudFront distribution for delivery with Amazon S3 as the origin. The web application communicates with Amazon API Gateway regional endpoints. The API Gateway APIs call AWS Lambda functions that store metadata in an Amazon Aurora serverless database and put the documents into an S3 bucket. The company is growing steadily and has completed a proof of concept with its largest customer. The company must improve latency outside of Europe. Which combination of actions will meet these requirements? Choose 2. A. Enable S3 transfer acceleration on the S3 bucket. Ensure that the web application uses the transfer acceleration signed URLs. B. Create an accelerator in AWS Global Accelerator. Attach the accelerator to the CloudFront distribution. C. Change the API Gateway regional endpoints to edge optimized endpoints. D. Provision the entire stack in 2 other locations that are spread across the world. Use global databases on the Aurora serverless cluster. E. Add an Amazon RDS proxy between the Lambda functions and the Aurora serverless database. A North American company with headquarters on the East Coast is deploying a new web application running on Amazon EC2 in the US East 1 region. The application should dynamically scale to meet user demand and maintain resiliency. Additionally, the application must have disaster recovery capabilities in an active-passive configuration with the US West 1 region. Which steps should a solutions architect take after creating a VPC in the US East 1 region? A. Create a VPC in the US West 1 region. Use inter-region VPC peering to connect both VPCs. Deploy an application load balancer, ALB, spanning multiple availability zones, AZs, to the VPC in the East 1 region. Deploy EC2 instances across multiple AZs in each region as part of an auto-scaling group spanning both VPCs and served by the ALB. B. Deploy an application load balancer, ALB, spanning multiple availability zones, AZs, to the VPC in the US East 1 region. Deploy EC2 instances across multiple AZs as part of an auto-scaling group served by the AL. Deploy the same solution to the US West 1 region. Create an Amazon Route 53 record set with a failover routing policy and health checks, enabled to provide high availability across both regions. C. Create a VPC in the US West 1 region. Use inter-region VPC peering to connect both VPCs. Deploy an application load balancer, ALB, that spans both VPCs. Deploy EC2 instances across multiple availability zones as part of an auto-scaling group in each VPC served by the ALB. Create an Amazon Route 53 record that points to the ALB. D. Deploy an application load balancer, ALB, spanning multiple availability zones, AZs, to the VPC in the East 1 region. Deploy EC2 instances across multiple AZs as part of an auto-scaling group served by the ALB. Deploy the same solution to the US West 1 region. Create separate Amazon Route 53 records in each region that point to the ALB in the region. Use Route 53 health checks to provide high availability across both regions. A company has a web application that allows users to upload short videos. The videos are stored on Amazon EBS volumes and analyzed by custom recognition software for categorization. The website contains static content that has variable traffic with peaks in certain months. The architecture consists of Amazon EC2 instances running in an auto-scaling group for the web application, and EC2 instances running in an auto-scaling group to process an Amazon SQ. The company wants to re-architect the application to reduce operational overhead using AWS managed services where possible and remove dependencies on third-party software. Which solution meets these requirements? A. Use Amazon ECS containers for the web application and Spot instances for the auto-scaling group that processes the SQ. Replace the custom software with Amazon Recognition to categorize the videos. B. Store the uploaded videos in Amazon EFS and mount the file system to the EC2 instances for the web application. Process the SQ with an AWS Lambda function that calls the Amazon Recognition API to categorize the videos. C. Host the web application in Amazon S3. Store the uploaded videos in Amazon S3. Use S3 event notification to publish events to the SQ. Process the SQ with an AWS Lambda function that calls the Amazon Recognition API to categorize the videos. D. Use AWS Elastic Beanstalk to launch EC2 instances in an auto-scaling group for the web application and launch a worker environment to process the SQ. Replace the custom software with Amazon Recognition to categorize the videos. A company is using multiple AWS accounts. The DNS records are stored in a private hosted zone for Amazon Route 53 in Account A. The company's applications and databases are running in Account BA solutions. Architect will deploy a two-tier application in a new VPC. To simplify the configuration, the db.example.com CNAME record set for the Amazon RDS endpoint was created in a private hosted zone for Amazon Route 53. During deployment, the application failed to start. Troubleshooting revealed that db.example.com is not resolvable on the Amazon EC2 instance. The solution's architect confirmed that the record set was created correctly in Route 53. Which combination of steps should the solution's architect take to resolve this issue? Choose 2. A. Deploy the database on a separate EC2 instance in the new VPC. Create a record set for the instance's private IP in the private hosted zone. B. Use SSH to connect to the application tier EC2 instance. Add an RDS endpoint IP address to the /etc/resolve.conf file. C. Create an authorization to associate the private hosted zone in Account A with the new VPC in Account BD. Create a private hosted zone for the example.com domain. In Account B, configure Route 53 replication between AWS accounts. A. Associate a new VPC in Account B with a hosted zone in Account A. Delete the association authorization in Account A. A company manufactures smart vehicles. The company uses a custom application to collect vehicle data. The vehicles use the MQTT protocol to connect to the application. The company processes the data in 5-minute intervals. The company then copies vehicle telematics data to on-premises storage. Custom applications analyze this data to detect anomalies. The number of vehicles that send data grows constantly. Newer vehicles generate high volumes of data. The on-premises storage solution is not able to scale for peak traffic, which results in data loss. The company must modernize the solution and migrate the solution to AWS to resolve the scaling challenges. Which solution will meet these requirements with the least operational overhead? A. Use AWS IoT Greengrass to send the vehicle data to Amazon Managed Streaming for Apache Kafka, Amazon MSK. Create an Apache Kafka application to store the data in Amazon S3. Use a pre-trained model in Amazon SageMaker to detect anomalies. B. Use AWS IoT Core to receive the vehicle data. Configure rules to route data to an Amazon Kinesis Data Firehose delivery stream that stores the data in Amazon S3. Create an Amazon Kinesis Data Analytics application that reads from the delivery stream to detect anomalies. C. Use AWS IoT Fleetwise to collect the vehicle data. Send the data to an Amazon Kinesis data stream. Use an Amazon Kinesis Data Firehose delivery stream to store the data in Amazon S3. Use the built-in machine learning transforms in AWS Glue to detect anomalies. D. Use Amazon MQ for RabbitMQ to collect the vehicle data. Send the data to an Amazon Kinesis Data Firehose delivery stream to store the data in Amazon S3. Use Amazon Lookout for metrics to detect anomalies. A company operates quick-service restaurants. The restaurants follow a predictable model with high sales traffic for 4 hours daily. Sales traffic is lower outside of those peak hours. The point-of-sale and management platform is deployed in the AWS cloud and has a backend that is based on Amazon DynamoDB. The database table uses provisioned throughput mode with 100,000 RCUs and 80,000 WCUs to match known peak resource consumption. The company wants to reduce its DynamoDB cost and minimize the operational overhead for the IT staff. Which solution meets these requirements most cost-effectively? A. Reduce the provisioned RCUs and WCUs. B. Change the DynamoDB table to use on-demand capacity. C. Enable DynamoDB auto-scaling for the table. D. Purchase 1-year reserve capacity that is sufficient to cover the peak load for 4 hours each day. A company is planning a one-time migration of an on-premises MySQL database to Amazon Aurora MySQL in the US East 1 region. The company's current internet connection has limited bandwidth. The on-premises MySQL database is 60 terabytes in size. The company estimates that it will take a month to transfer the data to AWS over the current internet connection. The company needs a migration solution that will migrate the database more quickly. Which solution will migrate the database in the least amount of time? A. Request a 1 gigabit per second AWS Direct Connect connection between the on-premises data center and AWS. Use AWS Database Migration Service, AWS DMS, to migrate the on-premises MySQL database to Aurora MySQL. B. Use AWS Data Sync with the current internet connection to accelerate the data transfer between the on-premises data center and AWS. Use AWS Application Migration Service to migrate the on-premises MySQL database to Aurora MySQL. C. Order an AWS Snowball Edge device. Load the data into an Amazon S3 bucket by using the S3 interface. Use AWS Database Migration Service, AWS DMS, to migrate the data from Amazon S3 to Aurora MySQL. D. Order an AWS Snowball device. Load the data into an Amazon S3 bucket by using the S3 adapter for Snowball. Use AWS Application Migration Service to migrate the data from Amazon S3 to Aurora MySQL. A company wants to migrate virtual Microsoft workloads from an on-premises data center to AWS. The company has successfully tested a few sample workloads on AWS. The company also has created an AWS site-to-site VPN connection to a VPC. A solutions architect needs to generate a total cost of ownership (TCO) report for the migration of all the workloads from the data center. Simple Network Management Protocol (SNMP) has been enabled on each VM in the data center. The company cannot add more VMs in the data center and cannot install additional software on the VMs. The discovery data must be automatically imported into AWS Migration Hub. Which solution will meet these requirements? A. Use the AWS Application Migration Service Agentless Service and the AWS Migration Hub strategy recommendations to generate the TCO report. B. Launch a Windows Amazon EC2 instance. Install the Migration Evaluator Agentless Collector on the EC2 instance. Configure Migration Evaluator to generate the TCO report. C. Launch a Windows Amazon EC2 instance. Install the Migration Evaluator Agentless Collector on the EC2 instance. Configure Migration Hub to generate the TCO report. D. Use the AWS Migration Readiness Assessment tool inside the VPC. Configure Migration Evaluator to generate the TCO report. A company wants to record key performance indicators, KPIs, from its application as part of a strategy to convert to a user-based licensing schema. The application is a multi-tier application with a web-based UI. The company saves all log files to Amazon CloudWatch by using the CloudWatch agent. All logins to the application are saved in a log file. As part of the new license schema, the company needs to find out how many unique users each client has on a daily basis, weekly basis, and monthly basis. Which solution will provide this information with the least change to the application? A. Configure an Amazon CloudWatch Logs metric filter that saves each successful login as a metric. Configure the username and client name as dimensions for the metric. B. Change the application logic to make each successful login generate a call to the AWS SDK to increment a custom metric that records user name and client name dimensions in CloudWatch. C. Configure the CloudWatch agent to extract successful login metrics from the logs. Additionally, configure the CloudWatch agent to save the successful login metrics as a custom metric that uses the user name and client name as dimensions for the metric. D. Configure an AWS Lambda function to consume an Amazon CloudWatch log stream of the application logs. Additionally, configure the Lambda function to increment a custom metric in CloudWatch that uses the username and client name as dimensions for the metric. A company is migrating a legacy application from an on-premises data center to AWS. The application uses MongoDB as a key-value database. According to the company's technical guidelines, all Amazon EC2 instances must be hosted in a private subnet without an internet connection. In addition, all connectivity between applications and databases must be encrypted. The database must be able to scale based on demand. Which solution will meet these requirements? A. Create new Amazon Document DB with MongoDB compatibility. Tables for the application with provisioned IOPS volumes. Use the instance endpoint to connect to Amazon Document DB. B. Create new Amazon DynamoDB tables for the application with on-demand capacity. Use a gateway VPC endpoint for DynamoDB to connect to the DynamoDB tables. C. Create new Amazon DynamoDB tables for the application with on-demand capacity. Use an interface VPC endpoint for DynamoDB to connect to the DynamoDB tables. D. Create new Amazon Document DB with MongoDB compatibility tables for the application with provisioned IOPS volumes. Use the cluster endpoint to connect to Amazon Document DB. A company is using an on-premises Active Directory service for user authentication. The company wants to use the same authentication service to sign in to the company's AWS accounts, which are using AWS organizations. AWS site-to-site VPN connectivity already exists between the on-premises environment and all the company's AWS accounts. The company's security policy requires conditional access to the accounts based on user groups and roles. User identities must be managed in a single location. Which solution will meet these requirements? A. Configure AWS IAM Identity Center, AWS Single Sign-On, to connect to Active Directory by using SAML 2.0. Enable automatic provisioning by using the System for Cross-Domain Identity Management, SCIM, version 2.0 protocol. Grant access to the AWS accounts by using attribute-based access controls, ABACs. B. Configure AWS IAM Identity Center, AWS Single Sign-On, by using IAM Identity Center as an identity source. Enable automatic provisioning by using the System for Cross-Domain Identity Management, SCIM, version 2.0 protocol. Grant access to the AWS accounts by using IAM Identity Center permission sets. C. In one of the company's AWS accounts, configure AWS Identity and Access Management, IAM, to use a SAML 2.0 identity provider. Provision IAM users that are mapped to the federated users. Grant access that corresponds to appropriate groups in Active Directory. Grant access to the required AWS accounts by using cross-account IAM users. A. In one of the company's AWS accounts, configure AWS Identity and Access Management, IAM, to use an OpenID Connect, OIDC, identity provider. Provision IAM roles that grant access to the AWS account for the federated users that correspond to appropriate groups in Active Directory. Grant access to the required AWS accounts by using cross-account IAM roles. A company is using an organization in AWS organizations to manage hundreds of AWS accounts. A solutions architect is working on a solution to provide baseline protection for the Open Web Application Security Project. OWASP, Top 10 Web Application Vulnerabilities. The solutions architect is using AWS WAF for all existing and new Amazon CloudFront distributions that are deployed within the organization. Which combination of steps should the solutions architect take to provide the baseline protection? Choose 3. A. Enable AWS config in all accounts. B. Enable Amazon Guard Duty in all accounts. C. Enable all features for the organization. D. Use AWS Firewall Manager to deploy AWS WAF rules in all accounts for all CloudFront distributions. E. Use AWS Shield Advanced to deploy AWS WAF rules in all accounts for all CloudFront distributions. F. Use AWS Security Hub to deploy AWS WAF rules in all accounts for all CloudFront distributions. A company runs a serverless application in a single AWS region. The application accesses external URLs and extracts metadata from those sites. The company uses an Amazon Simple Notification Service, Amazon SNS topic, to publish URLs to an Amazon Simple Queue service, Amazon SQS-Queue. An AWS Lambda function uses the queue as an event source and processes the URLs from the queue. Results are saved to an Amazon S3 bucket. The company wants to process each URL in other regions to compare possible differences in site localization. URLs must be published from the existing region. Results must be written to the existing S3 bucket in the current region. Which combination of changes will produce multi-region deployment that meets these requirements? Choose 2. A. Deploy the SQS queue with the Lambda function to other regions. B. Subscribe the SNS topic in each region to the SQS queue. C. Subscribe the SQS queue in each region to the SNS topic. D. Configure the SQS queue to publish URLs to SNS topics in each region. E. Deploy the SNS topic and the Lambda function to other regions. A company has VPC flow logs enabled for its NAT gateway. The company is seeing action equals ASAP-T for inbound traffic that comes from public IP address 198.51.100.2 destined for a private Amazon EC2 instance. A solutions architect must determine whether the traffic represents unsolicited inbound connections from the Internet. The first 2 octets of the VPCIDR block are 203.0.WHICH set of steps. Should the solutions architect take to meet these requirements? A. Open the AWS CloudTrail console. Select the log group that contains the NAT Gateway's Elastic Network Interface and the private instance's Elastic Network Interlace. Run a query to filter with the destination address set as like 203.0 and the source address set as like 198.51.100. Run the stats command to filter the sum of bytes transferred by the source address and the destination address. B. Open the Amazon CloudWatch console. Select the log group that contains the NAT Gateway's Elastic Network Interface and the private instance's Elastic Network Interface. Run a query to filter with the destination address set as like 203.0 and the source address set as like 198.51.100. Run the stats command to filter the sum of bytes transferred by the source address and the destination address. C. Open the AWS CloudTrail console. Select the log group that contains the NAT Gateway's Elastic Network Interface and the private instance's Elastic Network Interface. Run a query to filter with the destination address set as like 198.51.100.2 and the source address set as like 203.0. Run the stats command to filter the sum of bytes transferred by the source address and the destination address. D. Open the Amazon CloudWatch console. Select the log group that contains the NAT Gateway's Elastic Network Interface and the private instance's Elastic Network Interface. Run a query to filter with the destination address set as like 198.51.100.2 and the source address set as like 203.0. Run the stats command to filter the sum of bytes transferred by the source address and the destination address. A company has many services running in its on-premises data center. The data center is connected to AWS using AWS Direct Connect (DX) and an IPsec VPN. The service data is sensitive, and connectivity cannot traverse the internet. The company wants to expand into a new market segment and begin offering its services to other companies that are using AWS. Which solution will meet these requirements? A. Create a VPC endpoint service that accepts TCP traffic, host it behind a network load balancer, and make the service available over DX. B. Create a VPC endpoint service that accepts HTTP or HTTPS traffic, host it behind an application load balancer, and make the service available over DX. C. Attach an internet gateway to the VPC and ensure that network access control and security group rules allow the relevant inbound and outbound traffic. D. Attach a NAT gateway to the VPC and ensure that network access control and security group rules allow the relevant inbound and outbound traffic. A company's factory and automation applications are running in a single VPC. More than 20 applications run on a combination of Amazon EC2, Amazon Elastic Container Service, Amazon ECS, and Amazon RDS. The company has software engineers spread across 3 teams. One of the 3 teams owns each application, and each team is responsible for the cost and performance of all of its applications. Team resources have tags that represent their application and team. The teams use IAM access for daily activities. The company needs to determine which costs on the monthly AWS bill are attributable to each application or team. The company also must be able to create reports to compare costs from the last 12 months and to help forecast costs for the next 12 months. A solutions architect must recommend an AWS billing and cost management solution that provides these cost reports. Which combination of actions will meet these requirements? Choose 3. A. Activate the user-defined cost allocation tags that represent the application and the team. B. Activate the AWS-generated cost allocation tags that represent the application and the team. C. Create a cost category for each application in billing and cost management. D. Activate IAM access to billing and cost management. E. Create a cost budget. F. Enable Cost Explorer. A company has a legacy application that runs on multiple NET framework components. The components share the same Microsoft SQL Server database and communicate with each other asynchronously by using Microsoft Message Queuing, MSMQ. The company is starting a migration to containerized .NET Core components and wants to refactor the application to run on AWS. The .NET Core components require complex orchestration. The company must have full control over networking and host configuration. The application's database model is strongly relational. Which solution will meet these requirements? A. Host the .NET Core components on AWS App Runner. Host the database on Amazon RDS for SQL Server. Use Amazon Event Bridge for asynchronous messaging. B. Host the .NET Core components on Amazon Elastic Container Service, Amazon ECS, with the AWS Fargate launch type. Host the database on Amazon DynamoD. Use Amazon Simple Notification Service, Amazon SNS, for asynchronous messaging. C. Host the .NET Core components on AWS Elastic Beanstalk. Host the database on Amazon Aurora PostgreSQL Serverless v2. Use Amazon Managed Streaming for Apache Kafka, Amazon MSK, for asynchronous messaging. D. Host the NE Core components on Amazon Elastic Container Service, Amazon ECS, with the Amazon EC2 launch type. Host the database on Amazon Aurora MySQL Serverless v2. Use Amazon Simple Queue Service, Amazon SQS, for asynchronous messaging. A company has implemented a new security requirement. According to the new requirement, the company must scan all traffic from corporate AWS instances in the company's VPC for violations of the company's security policies. As a result of these scans, the company can block access to and from specific IP addresses. To meet the new requirement, the company deploys a set of Amazon EC2 instances in private subnets to serve as transparent proxies. The company installs approved proxy server software on these EC2 instances. The company modifies the route tables on all subnets to use the corresponding EC2 instances with proxy software as the default route. The company also creates security groups that are compliant with the security policies and assigns these security groups to the EC2 instances. Despite these configurations, the traffic of the EC2 instances in their private subnets is not being properly forwarded to the Internet. What should a solutions architect do to resolve this issue? A. Disable source destination checks on the EC2 instances that run the proxy software. B. Add a rule to the security group that is assigned to the proxy EC2 instances to allow all traffic between instances that have this security group. Assign this security group to all EC2 instances in the VPC. C. Change the VPC's DHCP options set. Set the DNS server options to point to the addresses of the proxy EC2 instances. D. Assign one additional elastic network interface to each proxy EC2 instance. Ensure that one of these network interfaces has a route to the private subnets. Ensure that the other network interface has a route to the Internet.